comments, back again, square one. Tried to leave myself behind, looking for a better place, not to stay alone. Gain our trust and you chose to break it. Ask for truth but you only fake it. Thought you said what we had was sacred. It's all lies, all lies. I was broken and isolated, but inside held the fire waiting. Not a word that you say can save this, so don't try, 'cause this time you crossed the line. Didn't think I'd go this far, but here we are, the end. Now you're just a lesson learned, a slowly fading memory, so I can breathe again. Gain our trust and you chose to break it. Ask for truth but you only fake it. Thought you said what we had was sacred. It's all lies, all lies. I was broken and isolated, but inside held the fire waiting. Not a word that you say can save this, so don't try, 'cause this time you crossed the line.
Hey folks, how's everybody doing today? Happy Monday. Right. Okay, now I got my mug from Dr. McLive. Fantastic. See if he's online later tonight, maybe we'll rate him. It usually starts later. Oh, zero, yeah, some of the Twitch ads. We haven't got hit with the Spotify ad yet. Alright. Here we go. So, week 2 already. We're going to cover Chapter 2, Java Fundamentals, and talk about our first project. We'll have a little extra time for our first project because of Memorial Day. Remember, no class Monday. So that'll be due actually on 6/7, the evening of at 6 p.m., because I'm going to go over the solution that day. Moxie, all right, my little kitten, wants to see everybody. Say hi. Say hi, baby. Please feel free to post your pet pictures in the pets channel, so it's not just me posting pictures of my kittens in our Discord. Exclaim Discord there if you don't have the link yet. Alright, so that's all tonight is Chapter 2. The Chapter 1 quiz is due tonight, 11:59 p.m. for that quiz. The syllabus quiz was due by 6, and I think all of you folks got it in on time, which is great. Had a bunch to grade, which is good. You are welcome to retake the syllabus quiz, so if you didn't get 100%, go ahead and retake it. I know the due date is now, but I'll still take that one in late. Those were supposed to be free points for you folks for reading the syllabus, okay? So go ahead and do that. The Chapter 1 quiz, again, by 11:59 p.m. So if you have any questions about that, do let me know. Hi, baby. You coming up? All right, go for it. Go on up. Go on. Go on. Go for it. All right. So after, we'll talk about this one next week if you have any specific questions about the Chapter 1 quiz. And then we'll just do one quiz per chapter as we cruise through the material here. Oh, and I do have office hours. I forgot to update this one here, so let me go grab that. Let's go add this in. So I looked at the when to meet here, and it looks like the best time is about like 3 to 4:30-ish Monday and Wednesday. A bunch of you forgot the directions, and maybe other classes probably put in 6 p.m. or so was a good time, but I said nothing, 5 to 10. And then it looks like a couple people wanted to make it Mondays and maybe even Wednesdays at about 10 p.m. or so. So I'll put those in for standing office hours. So I'll do like 3 to 4:30 Monday and Wednesday. Seems to be a pretty good slot there. Again, I'm breaking for dinner about 5 and a class at 6, Monday, Tuesday, Wednesday, Thursday. So I'll have those for standing office hours here. So do Monday, Wednesday from 3 p.m. to 4:30 p.m. And also 10 p.m. Oops. Oh my goodness. 10 p.m. Why did I want to do an emoji? to 11 p.m. So you're welcome to book appointments with that if you want. Just drop in. I'll be around at my computer, able to answer questions quickly. We can do some screen sharings. If those times don't work for you, I can still do things by appointment, right? Sweetie, stop trying to climb up on my computer. Or by appointment. Okay? So I'll save that one up there, and I'll just upload that one. That was the only change here, so I'm not too concerned about marking it another version. I'll just drop that in here because now it has my office hours. Okay, so thanks for filling it out. Again, if that doesn't work for you, let me know. We can always make an appointment and go from there. Sweetie, that's a fan. I think she likes my fan. No, don't run on the keyboard. Don't run on the keyboard. All right, she might have to leave the office. I thought this was going to work out well, but apparently not. All right, any other questions, thoughts, concerns before we get moving into Chapter 2? I think almost all of you got the first assignment in. Is that right? We've got 30 people in the class, so let's take a peek. 21 of them got turned in. Oh, there's not as many as I thought. I've got a couple. I was trying to grade them as they came in, if I could. I know one person was going to turn it in late. They had a decent excuse. But we definitely need this to be working. Right? If you can't get Project Zero in, you're not going to be able to get any of the projects turned in. So do let me know if you're having trouble with that. Hopefully you found some learning partners. I saw some discussion. It was not required that you post in there. Just strongly recommended that you find a learning partner, somebody you can chat with and meet throughout the class. And then don't forget as well, we do have the weekly supplemental instruction study group sessions. Those are in the calendar here as well. So that'll be the 19th from 5 to 6 p.m. if you make that. They get you a bonus point. It's proven to improve your scores for students who attend supplemental instruction sessions, which is pretty cool. Statistically significant. That's what the term I was looking for. It's statistically significant to improve your grade. They're able to find improved grades. I think the printing was off on this. Like, this is centered, but like I have to turn it a little bit so you can see the U matter there. For a shout out for Dr. Mick Live. It's fantastic. I think I can even shout him out. Look at that, it works. All right. What are you doing, sweetie? Go sit in the window. All right, so we're all set then to keep moving. Let me open up GitHub here. Ouch. Baby girl. So remember, I'm going to put all of my code examples that I do in class here in this public repository, 1500 summer 2021. So as I put new projects in here, they'll show up. Oh, I had a Hello World project. Did I forget to do that? That's weird. I forgot to commit that. I'm sorry. So this was last week. Hello World. So it said, hey, they found some new files. I'm going to commit and push. It'll synchronize it, send everything up to github.com. And you folks can go find that. The link is out here in content, in the course information. That is the... I didn't add the link. I thought I added the link. Great link. Here's the course repository. And let's go grab that. So you go to the repository menu, click View on GitHub, and it'll pop open the link for you. There we go. Yes, I know. Okay, so you see the Hello World here, and then remember you can just click on the folders. It will open up, show you the contents. All of our code goes in the source folder here, and then helloworld.java, and you can take a peek at all the things that we do. Okay. All right, so let me fire up NetBeans here. And again, the Gradle stuff was not cooperating. I got it to work by upgrading Gradle. It's only a small pain, and then it still gives you errors, so we'll probably forget all the Gradle stuff and just go with Java with Ant, because that is easier. So that's the Java with Ant project we'll take a look at. Hey. Yeah, go to sleep. Take a nap. All right. So again, I'm going to go to File, New Project. This is the Java with Ant category here, a Java application. And when it asks, where do you want to put it, your project location, this is the one. For you, it's going to be the Project 0, Project 1, -- as I make them for you. Yeah, Maven's fine too, P-Slavs. That's no problem. I have the least problems with Ant. Yeah, either one's fine. Or if you prefer IntelliJ or VS Code, or I've had people use a couple different editors before. Not too much of a problem. I still have to figure out the auto-grading stuff now that Gradle wasn't playing, so should be fine. Hi, baby. So for me, I don't want it in this Project Zero folder. That was the example one I had. So I had that Project Zero repository. For me, I want the Show and Explorer, this 1500 examples. So it's in my users, documents, GitHub folder. That's the default location. And in NetBeans, I can either browse or I prefer to copy paste. So I'm going to paste that in here. And this will be chapter 2. So the project name will create a folder inside of that folder with the project name, which is great. And make sure this use dedicated library is not checked. You don't want that box checked. Okay? Hey. Man, when we go back in person, I hope I can bring my cats with me. That would be fantastic. Although some of you might be allergic, so maybe that's a bad idea. It would be sweet if they could just hang out in my office. All right. So you might notice there's these couple things here. These are multi-line comments. I'm just going to get rid of them for now. We'll talk about those in just a minute here, what they all mean. But I think it just clutters it up for now. All right, and I've got my package, the Darkula package installed. I figured that out finally. So everything is good. It's not bright and should be easy to see. Let me know if you have any trouble there. You just take the Benadryl, Azusa. So that's my brother. When we were growing up, he was so allergic to cats. My grandmother had cats. I'd love to go play with them, but we never had cats because he was allergic. Yeah, Starting Out with Java by Tony Gaddis. That is the correct textbook. If you do ! book there in chat, it should link you to it, or give you the ISBN at least. And that's what we're covering is Chapter 2, Starting Out with Java by Mr. Gaddis. That is our text. So I don't do PowerPoints. I don't like when people read to me, so I will try not to read to you. The PowerPoints are there in D2L if you want them, because I'm assuming everyone's going to buy the textbook. It is your main resource. All right, so and this to-do code application logic here, that's our main place where we start. So everything we do for now is going to start inside of this public static void main string, square braces, args, and parentheses, start curly brace. So there's all sorts of Java syntax. Right? The syntax is the rules of how we have to write our code so that the computer can understand what we're doing. So we get a package here, we get a public class here, and you'll notice the name of the class actually matches the name of the file. So I'm going to open up this project view on the left. This is a package, this little square box there. Inside of that is a chapter2.java. So case for case, letter for letter, the name of the class here after public class has to match the name of the file. Again, NetBeans does this magic for us. Other editors, not so much. If you try and make new files, that sort of thing, they don't happen automatically. Okay, so you'll see that's the same. The package name is the name of the package here. And a package is just a folder. So if I hover over the project here, I get a path. It says C users, Eric C, documents, GitHub, CIS 1500, summer 2021, /chapter 2. So that's the project location. Yeah, we're going to have a public class for every project. Yep, this was started from scratch, 0. Brand new, file, new project, Java with Ant. Now, you wouldn't need to rename anything. If you want to rename it, you can. Don't just retype. Like if you just type over here like chapter 2 and you want to say like examples, it's going to yell at us right away when we get this nice red line here. And it'll say, oh, class chapter 2 examples is public, should be declared in the file named chapter2examples.java. Yeah, the blue is a little difficult there. I'm sorry. The dark mode got a little funny there. So these little light bulbs are super helpful. They suggest, hey, do you want to rename your file? You could do that, or just leave it alone. Or you could right-click and go to Refactor Rename. And if you refactor rename, it's going to do all that for you, which is awesome. So I could do chapter 2 examples here and say refactor. And now it changes the name of the file for me automatically. Okay, so always use your tools, right? Good developers are lazy. We're going to use our tools to do the hard work for us. Okay, but again, I'm just going to really undo the rename. Thanks for confirming. And then we have a set of curly braces. So curly braces define scope. So everything inside of curly braces belong to the thing where they start the curly braces. All right, sweetie, you gotta get down. So all of our code is going to go inside of main currently. Public static void main, parentheses, string, square braces, args, and parentheses, start a curly brace. And if you click on a curly brace, it'll highlight the other one for you. It'll show you, oh, hey, here's where the other curly brace belongs. And you can also kind of see in the left view here, I got my line numbers, and then there's these little arches here that show you the end and the start of each one of these blocks here. Oh, there's a block of code. Okay? Awesome. So let me grab this before I forget. Stop, sweetie. Okay. All right, okay. I'm going to grab this and kind of follow along. Excuse me. Let's see. There we go. That ought to do it. Okay. So parts of our Java program. Again, a Java source code. This is called source code. Source code is written for people to read, but it has to comply with the syntax rules so that the computer can also read it. Right? So, funny thing about Java is that it doesn't care at all about white space. The white space here is really for people. And some people go through lots and lots of arguments about whether or not curly braces should start at the same indentation level or if they should start after the line that they end. Okay? So either way is perfectly fine. I am very partial to being lazy, as you've noticed, so I take the default. So if you do Shift-Alt-F, that is the auto format button in NetBeans, and it will format it to the default formatting. Hey Veda, how you doing today? So I will typically put my curly braces here at the end of the line because that's how it auto formats. Again, it really doesn't matter. The white space is for people. So if we put a little comment or a command out here, the system.out.println, again, SOUT and then tab will fill it out for you. Yeah, this is 1500, Veda. So I can put out here like, hi there, right? And if I give it a run, yes, run chapter 2 main, that's okay. Oh yeah, the ad will go away in a second, sorry. It supports the Twitch platform. Alright, so we get hi there. Again, white space is for people, so I can put all of this onto one stupid line if I so cared to. And Java would care less. So let's just keep on going that way. Let's see, am I all on one line here? Nope, almost on one line. There we go. So I have a one-line Java program here. And I'll hit run, and Java could care less. It's still going to give me hi there. All right? But this is terrible. Right? This is not readable. So a typical rule of thumb is that you don't want to have to scroll to the right when you're reading code. That's offensive, right? Because we're lazy. If I have to do something to see all of your code, I'm going to be upset. Okay? So just try and keep it all viewable in the same screen, and you should be fine. Right? So you don't want to have to scroll left and right. That's the typical rule of thumb. Okay? Again, it's because our code is for people. We want people to be able to read it. Ideally, what's going to happen is you are going to write amazing programs in your professional career that will live longer than you will be at that position supporting it. So you'll be tasked to write a program, and then you'll move on to bigger and better things, and some poor new person will have to support it. And they're going to have to read your code and understand what you did. Okay? So we want to imagine that the person who comes after you is a crazed monster, and they're going to come after you if your code is messy and gross and unreadable. Okay? So remember, write it for people. And again, in terms of this class, this is NetBeans, Veda. In terms of this class, you want to write code so that I can read it because I have to be able to read it to evaluate it for you. Right? If you want to get a score, it has to be readable to me. Okay? Because I need to be able to read your code and score it. So in the professional world, you write code so other people can read it. Here in class, you write it so I can read it. Your instructor can read it. Okay? Some cool stuff. You can actually run Java from the command line if you so care to. Again, I'm not so big on that exactly, but it is doable. So what happens here, we looked at this briefly, I think. You look at this folder, Hello World. And remember, anything that we can create in NetBeans, anything that we can build off of the source code does not go in GitHub. So we go to GitHub, it'll say, hey, I see some new stuff here, but it's not everything that's in the folder. It doesn't include the build or distribution folders because this stuff is generated when you build your project and run it. Okay? So what's inside of here is a jar. A jar is just a package that you can run. It's a Java package that you can run. And a little README file. And here's the build. So build has this classes section here. And here's the Hello World package, helloworld.class. Remember, .class is the Java bytecode file that's been compiled from your .java file. So the .java files get compiled into .class files, And on any particular machine that has a Java virtual machine installed, it will run the class code and talk to the operating system, which talks to the hardware to do all the things that you ask it to do. So these little class files are portable, and essentially a jar is just a package of class files, one or more class files that you could ship around. So the class file here has all of the Java instructions to do our code. And if we try and open it and view it, and like open a little text editor here, it's mostly garbage. Not all garbage, but mostly garbage, meaning we can't read it because it's in binary form. So it's not just plain text. So this is not in text format. This is Java bytecode. Again, you see some things here, right? See a name, that's interesting. I see hello world there. I don't know, you see some stuff, but most of it's junk because we can't read it. But the Java virtual machine can read that for you. So you can run Java code from the command line if you want. You don't have to do it in NetBeans. And this little README, I think, will tell you how to do it. Java, jar, hello world.jar. That's how you can run our program. So again, I'm not going to ask you to do this, but it's interesting. So I'm going to go to, nope, that's the wrong thing. I'll just go to my terminal. That's fine. Forget that. Not my power options. I was trying to find PowerShell. I also have it in Windows Terminal. So you won't need to navigate around here too much, but that's okay. You should pick it up at some point, but it's not all that important right now. So I'm going to go to my CIS 1500 summer folder, so CD for change directories, and then ls or dir will list the things. I have one called hello world, so I'll say cd hello world. Again, don't type everything. Right? If you start typing HE and hit tab, it'll autocomplete for you. And then we go to the distribution folder, and then we need to call Java. So if you have Java installed or on your path, this will run. Because we didn't do that, we didn't install the Oracle version, we need to go find Java. So we put it in OpenDev, we put it in the JDK, there's a bin directory for Java in here somewhere. I'm just going to keep hitting tab till I find it. There's java.exe. That is the exe I want to run. And in PowerShell, you actually have to put an ampersand there because it's silly. Don't worry about that. I'll say Java, and then I'll say -jar, and just like the directions here say, java-jar, hello world, .jar. Oh goodness, unable to access. Is it not here? It is here. Maybe I take out the quotes. Can't find it. How about that? Oh man, okay. Didn't even find it. That's unfortunate. I spelled hello. I did spell hello world wrong. Thank you. Undecked, you get like 10 bonus points for catching my typing error there, my spelling error. Hooray. And we get hello world. We get the output, the same thing we got from over here. We get hi there. Oh no, I'm in hello world. I'm not in project 2. I'm in the wrong one. Oh goodness. That was the wrong. Okay, so let me go back. CD dot dot to go up a directory. CD dot dot. Oh my goodness. Dot dot. 2 of them. CD chapter 2. There we go. If I go to my distribution folder. Nope. 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 Distribution folder. Oh goodness. Oh, there is no. I only built it. Okay, there's only the build folder. Run. I want to get my distribution folder. I'm confused. That's okay. Let's go back. Let's find chapter 2. There we go. Oh, I only have the build folder. That's okay. Sure. So we have classes here. We can go and run the class file directly too. So that must have been from the... Is that from the Gradle project, maybe? That's fun. Let's try that. So we'll go into our build directory, and then into classes, and then there's chapter 2. So we're going to do the same Java path. So C:, opendev, JDK, bin, java.exe, and then we just give it the chapter 2 dot... Oh, I got to go up one more directory. I forgot. Chapter 2. There's the class file. So C:, opendev, JDK, bin, java.exe. And you can see why we use tools, right? Having NetBeans do this is fantastic. At some point in the history, I don't remember when, some instructors liked having you do your very first project by hand and running all this stuff by hand. And it's a fun exercise, but the tools do all the work for us, which is fantastic. There's Java, and we give it chapter 2. And you actually just give it the name here. You don't give it the class, right? Oh, I'm up a directory here. Shoot. Chapter 2 dot chapter 2. Is that it? There we go. So I had to be up into the package level to say package.class. Because when you're in a package, you have to give the package name. Again, this is really obnoxious to do all this stuff by hand. So what you see here is ant. Ant is a tool that packages and kind of wraps all of these Java commands here. So what it's doing as it runs just is, oh, here, ant, it's calling run. Right? And then it will go and update, and it will compile. It will make your classes file here. And it will go and run it. Because ant does all that work for us. We don't have to do any of that work, which is awesome. There it is. Properties, sources. Yeah, we don't use any of those. So empty is empty, go figure. So all that work the build tool does for us. So we don't have to do any of this stuff by hand. Okay? That's the whole story there. There's also a tool there built in. If we go into sources, there's a javac command. So javac is the Java compiler. So if you want to compile it yourself, you can with the javac executable. Again, I'm not going to bother. And that was super exciting. All right. So getting back to our code here. Remember, this line here is a Java command, a statement. It ends with a semicolon. So every statement will end with a semicolon, but not every line of code. So this package here is a statement. This public class chapter 2 or public static void main string args, those are headers. Okay, this is the class header that defines the class. This is the method header that defines the method. So not everything has a semicolon, just the commands. Right? Things that are comments, you can put / for a comment. This is a single line comment here. Or if you want, you can do /* and then NetBeans will put in the ending */ for you. This is a multi-line comment. Comments are literally ignored by the Java compiler. So they only exist to leave notes here. I am generally anti-comment to a fault, which is a little bit unfortunate sometimes. Depending on which instructor you take, some of them are really big fans of comments. And I strongly disagree, but that's okay. So in general, comments are there for people. No, this is just the chapter 1 example 0. We'll talk about project 1 a little later tonight. Yep. So I'm going to talk about all of chapter 2 first, and then we'll get to what the project is. Because if I tell you what the project is, you won't, unless you've read chapter 2, you won't have any clue what you're supposed to be doing. Okay? So just going through some examples, looking at Java fundamentals here, how it all works. Again, so I'm not fond of comments here, so I'll never ask you to do them. Because I don't remember if I told you the story or not, but years and years and years ago, back in the winter of 2005, I took my very first Java class. I was actually a dual enrolled high school student, which was super cool because I got out of school an hour earlier than everyone else to go take my class. And I had an instructor actually at the Orchard Ridge campus. I went to OCC as a dual enrolled student, and I did my project. Everything worked. It was supposed to did all the things it was supposed to do, and I got marked down because I didn't have a comment that was required. And at that point, I swore to myself, if I was ever to teach, I would not mark someone down if their project did what it was supposed to do. Oh, Zero, I'm sorry. I keep getting disconnected. That's no fun. Yeah, I don't know what to tell you if you're getting disconnected. Is it just one of those nights with the internet? Yeah, so I swore to myself, if you got all the things done, you would get the points. And that's why all of your projects will have rubrics. And the rubrics will say, here's a point for this, here's a point for this, here's a point for this, here's a point for this. There will never be a point for a comment. Okay? Because it's just, if you can get the task done, you'll get the points, is my rule of thumb. And typically what we say in the industry is, and it's a little bit of a pipe dream, you know, that pie in the sky that's, you know, it's a good ideal but doesn't always work, is that code should be self-documenting. So we're going to talk a little about that as we go, as we start looking at other things we can do in our code. Right, so we have Java statements, we have class headers, we have method headers, we have these curly braces. Everything happens inside the main curly braces to start. Main lives inside of the class curly braces. Java is case sensitive, so if you were trying to do system.out.println with a lowercase s, because you typed it yourself, here it's going to complain at you. And this little light bulb will say, oh, hey, did you want this clock system? That's a bad suggestion. You don't want that. So not all of the suggestions are good. Only some of the suggestions are good. Okay? So capital S system.out.println, that is an L, not an I as well. So it is case sensitive. It's going to be a little upset with you. Okay? So we have parentheses. Those are the round ones. We have square braces. Those are those ones. We have curly braces. Okay? These are quotations, the double quote marks. You also have these single ones as well. These are just apostrophes here, but they're different than quotes, and they're not going to work. If you try and put something in there, it's going to be upset with us. You get unclosed character literal. Doesn't mean a whole lot to us right now, but that's okay. All right. So lots of different syntax rules we're going to get used to. Okay. Now the Java library is full of stuff that Java already knows how to do. We call that the API, or the Application Programming Interface. The Java API knows how to do all sorts of really cool things already for us. We don't have to reinvent the wheel. So system.out.println will print stuff out to the console. We don't have to figure out how to do that. Again, almost all languages will do this very easily for you. Okay? And that comes from the system library. So out is a class there, println is a method. Again, those don't mean a whole lot of things yet, but that's okay. There's also another command that's similar here. That's system.out.print without the ln. This is a printing without a new line. So with ln, it stands for line there. If you call print, it doesn't go down a line. So if you do another one of these, there's a second print without the new line. When you check out your output here, they're going to be on the same line right here because it didn't go down a line. So what system.out.println does for you is it puts it down a line when it's done. So it prints hi there, and then it goes down a line, which is really cool. So almost all the time we'll use lns, print lines. There are some cases where you might not want to. Just depends on what we're trying to output here. Actually, I guess I should leave that. ln, there we go. Here's a new line, finally. And now it's not going to put a new line at the beginning either. So the here's a new line, finally, is going to show up all the way at the end of that, because this one didn't put a new line at the end. So when you go to print again, it's still right there. Then at the end of that, it puts a new line down, so we get that funny build message. Okay, so that's console output. That's called our standard out. One way that you can, if you want to do your own new lines and special characters, so you can use system.out.print here, and you can have special characters for new lines. That's a \n. So backslash is called the escape character. It's an unusual character to print. So they picked backslash. So \n is for a new line, \t is for a tab, \b is for a backspace, which is really funny there. You can put quotes and other marks in here. So going down a line here, so this is adding in our own new line here. Or we could have something like this. We could say, here's, I don't know, if we wanted to have, Billy said, hi there. Notice it gets kind of upset with having these quote marks here. So I see the orange, which means it's a string. It means I can print it out here. And all of a sudden it goes back to gray. So if you want to have the quote mark outputted, you have to escape it with a backslash. I know, Quinn. Sometimes you need to do your own new lines, and when we get to graphical user interface programming, we can add in our own new lines with \n, because it works a little differently. We'll get to all that weeks and weeks and weeks from now. Okay, but if you want to put quotes in here, you need to have the \, quote. Otherwise, that mark won't show up. It's going to be really confused. So now I can get quotes in my output. Otherwise, it would just end it, and it's not going to compile. It's going to be really confused. Okay? All right, so this is just printing out to the console here. A couple different ways of printing. Again, yeah, print ln is almost always preferred. Using print is just kind of funny. Okay. Other really cool things we can do in Java is we can have things that are called variables. Now, a variable is a programmer-assigned variable. So we will say, hey, I want a name that's going to store a particular value. And what's really cool is we get to pick the name. So we need to tell Java what type it is. So if we want to store a string, that's capital S string, we'll say this is name. So it's the type and then our name for it. Okay, and we'll say equals, so for a string, I'll say my name is Eric Charneski. And then I need a semicolon. Right? This is a statement or a command here. So I'm going to tell Java, hey, go out and ask the operating system for a place to store a string in memory. Remember, memory is where we store, that's all of our quick access stuff. So when our program is running, everything is stored in memory. And I'm going to call it name inside of my program. So this is my name for it here. Right, and I'm going to assign it. So the equals sign here is actually the assignment operator. It does not mean equals. It means assign. So give it the value of Eric Charneski. Then what I can do here is I can print, and instead of putting it in quotes here, I can put name. And what it's going to do, it's going to go ask Java, hey, go get the thing that you stored somewhere in memory. Ask the operating system where that thing is, go get it, and put that in instead of a string here, a hard-coded string. So this is a variable here. This is a variable named name. Okay, and when it prints here, it'll print my name. It's pretty cool. Yep, in RAM. Yep, that's stored in memory, in a random access memory. Other cool things we can do. We can store other types. There are integers. So int, int is short for integer. Ints are whole numbers. Yeah, 0, you're retaining. That's awesome. So integers are whole numbers here. So I'll do this as my favorite number, and I'll assign it the value of 42. Sorry, the black there's coming out really funny. I don't know if I screwed up the Darkula theme or what, but it should have been fine. There's ways to change it somewhere. It's in look and feel. Where's look and feel? It's palettes. No. Not remembering it at the moment. No, maybe it's in options. Fonts and colors. Yeah, here's the Darkula profile. Can I restore? All I did was change the size, right? I wanted to go a little bit bigger here, 24. Aha, there we go. It fixed it. Yeah, look at that. Okay, and I got rid of the blue. Now I'm back to orange. That's so much better. I love it. Thank you so much. Ooh, and now my strings are green. There we go. Strings are green. We're back to normal. We're back to normal here. And now we can see again. Okay? Azusa, you get like 10 more bonus points. Or, no, you didn't get any before. 10 bonus points for you. Sadly, they're not actually worth anything. Okay, so my favorite number here, we're telling Java, hey, go store an integer. Here, so go ask the operating system for place to store an integer, and store there the number 42. Remember, this all gets stored in binary. Remember back to binary? We've checked out that Windows calculator here, which is really cool. And we'll go to our programmer calculator. And in decimal, if I put in 42, we can see in binary, that's the value 00101010. Here. Now, integers are special in Java. Integers can only be so big. Okay, and there's a reason for that. We'll take a look here in a second. So let's go look at this bit operation calculator here. And let's flip that one on here. So this is, remember, bits are grouped into 8 at a time for a byte. So this is 1 byte, this is 2 bytes, this is 3 bytes, this is 4 bytes here. Okay? So the largest integer you can store is 2,147,483,647. It's one less than this. Because what happens is integers can also be negative. So Java will use 4 bytes minus 1 bit. So 35, right? 8 times 4. No, 32. 32, I can do math. Minus 1. So it'll use 31 bits for the values here. So if we do all 31 of them, remember it's one less than the next bit here. That's a fun math fact for you folks. We'll toggle all these folks on here. Boop, 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 boop. There we go. 2,147,483,647. No, I'm reading it right from the calculator here. Right? It's showing on my screen, isn't it? You can see the calculator, right? Yeah. Okay, good. Yeah. So it uses 31 of the bytes to store the number, and then it uses 1 byte to store whether or not it is positive or negative. That's how you can have a negative value. So if it's there, it's negative. If it's off, it's positive, or something like that. And I'm not actually entirely sure. I'd have to go look it up again. It's really not worth remembering here. Okay? This is how we'd store an integer. So each integer in Java in memory will use 4 bytes of storage. So remember, your memory, it comes in like, usually you have so many gigabytes of memory, which is made up of so many megabytes of memory, which is made up of so many kilobytes of memory, which is made up of so many bytes of memory. Right, does that all ring a bell? So a gigabyte is about 1,000 megabytes. It's supposed to be 1024, but it's not for some reason, and that still kind of confuses me, but that's okay. And a megabyte is 1,000 kilobytes, and a kilobyte is 1,000 bytes, on and on and on and on and on. So we just use 4 bytes out of that 1,000 million billion, right? So a gigabyte is a billion bytes. Does that sound right? That sounds right. Because kilo's 1,000. 1,000 thousands is a million for a megabyte, and 1,000 millions is a billion for a gigabyte. Yeah. We can do math. We can do math. Okay. So when you ask Java to store an integer, it goes out and says, hey, I need 4 bytes of memory to store something, and then we'll go and flip those binary bits to 00101010. Actually, with a bunch of zeros in front of that as well, too. So we have the number 42. And then what we can do is you can also print the favorite number. Again, I'm not typing, right? Don't do more work than you need to. I'm typing FAV, and it pops up, hey, favorite number, and I hit tab to autocomplete. Okay, don't do more typing than you need to. If you're not getting those suggestions, go to Tools and Options and Editor and the Code Completion tab, go to the Java language, oh my goodness, and say you want auto pop-up on typing any Java identifier part. And I think subword completion as well. The guess method, field method arguments is fantastic as well. It's always nice when it guesses for you. So go check Editor, Code Completion, Java language, check the 3 boxes here, and you should be good. All right, so that way it'll pop up all those things. So favorite number is stored as an integer in 4 bytes in memory somewhere. Somewhere in memory, we don't know. We could care less. So Java asks the operating system, hey, where can I get 4 bytes? The operating system says, here you go, here's 4 bytes somewhere. And remember, memory is addressed in hexadecimal, and we don't really care. But so somewhere out in memory, we have a hexadecimal address that stores that information. And you know what's a funny thing? In our 64-bit operating systems, that means that all of our memory is addressed in 64 bits. So every memory address actually is its own 8 bytes. And again, that's sort of silly, but that's just a fun fact there for you. Okay, so we can print out favorite number. Okay, so we can get out our favorite number. Now we could say, you know, Eric's favorite number is, so we could print out here, we would say name plus. Now the plus operator here does some funny things. So if you give it a string and another string, is, like that, so name is a string, and quote, S's favorite number is a string, it's happy with that. It has no problem adding those together, but it's not actually adding. What it's doing is called string concatenation. It takes one string and another string and goes, stuck you together. Done. String concatenation. So the addition operator here does some fancy stuff. So right in my print line, I say, hey, Eric Chernesky's favorite number is, and then I can add another plus, I can say favorite number, and I probably actually want a space here. Remember when it sticks things together, it doesn't add any spaces for you? Let's try that. And then I can also concatenate on there an integer. And Java is smart enough to say, you have a string over here and you have a number over here. We can stick them together and we're okay. It doesn't try and say, hey, string plus a number and get really confused, because you can't add a number to a string. right? What is Eric's favorite number is plus 42. It doesn't make any sense. So it's turning 42 into a string to stick it on automatically. So println does some pretty cool stuff for us right there. Nope, so favorite number is an integer right here. Yep, so because it's in the print line here, it's smart enough to know that it will concatenate it together and not add. The print line is smart enough to concatenate the int with the string, not try to add. And sure, I'll bump that down one more line. Not try to add. Okay, but what you can do here, also in print lines, you can take favorite number and you could say like plus 10. Now, if you take an integer plus an integer, what do you think we're going to get? Do you think it's going to take 42 and 10 and stick them together? No, it's going to do the arithmetic. Int plus int, and you get arithmetic. Okay? So you have to be a little bit careful and know specifically what you're doing with that operator, the plus sign there. Okay? Other things here, because Java does care about new lines. So the tabbing and spacing and things it doesn't care about, but it does care about new lines here. So if you try and make a really long string and say, I'm going to tell you a joke here. Oh man, NetBeans is making it easy for me. If you just don't end your quote here and you just keep on going here, you know, what's a pirate's favorite letter, and you try and put it on 2 lines here, notice the coloring gets all off and it gets really confused. You can't have a string on more than 1 line. So Java is upset about that. So what you can do is you can end the string, and then you can append another string, like this. This way here. Ah, you think so, Zero, but it'd be the C. It's one of my favorite pirate jokes. You lost some bonus points for getting that answer wrong, I'm sorry. Minus 10 points for you, sir. Alright, yep, my kitten finally fell asleep on my lap. But she's like half falling off now. Her legs are dangling off the chair. Okay, so with multi-line strings, you need to append, right? That's the plus, concatenate, append, concatenate, and 8. Use the plus sign, plus operator. Here like that. And NetBeans is pretty good. So if it's, as I was typing here, like here's another pirate joke. If I just hit enter, NetBeans adds that for me because I'm inside the quote, and I hit enter, and it adds another one for me. Right? Where does a pirate keep their cookies? In a cookie jar. Now the problem is when these ones print here, I don't have any new lines. So this is all one long string. It's going to come out in 1 line because that's what I told it to do. If you want new lines, either do another system out print line or add in your own \ns. Either way is perfectly fine. Whichever you prefer, whatever you think is easiest, however you want to do it lazily. I'm good with it. Multi-line. Okay? So let me add another new line. Be the C. Okay? Now, other things we can do in here, and I don't recommend this here. Yeah, the new lines make a little bit of sense if you're doing it this way. Again, you could also just have a bunch of new print lines and not have to deal with the pluses. Totally up to you, whatever is easier for you. I'm not opinionated one way or the other. At the beginning or the end, doesn't matter. It would work if you want to put it at the end instead of the beginning. Yeah. Either way, Yule and Caw. Yep, both will work. Okay, so what's interesting here now is in my print lines, I can say, 10 times 10 equals, and I'm going to use a double equal sign because that in Java is the equivalent or equals, not a single equal sign, which is the assignment operator. And I'll add in here 10 times 10. 10 times 10. There we go. All right, so we can make Java do some math here. 10 times 10 equals 100. So if you're doing arithmetic inside of a print line, it's still relatively smart enough to do it, which is pretty cool, right? Pick up your butt. There you go, kitty. Don't wake up. Don't wake up. Just stay asleep. Okay, but most of the time, I'm not going to recommend you do arithmetic inside your print lines. What we usually would want to do is just have another variable. Essentially, variables, we'll say, are free, right? I mean, 4 extra bytes when you have billions of bytes is really minuscule. So I'm going to encourage you to use a variable as often as you want, as many variables as you want. So you might have a variable for, we'll say, an int. Here's my, I don't know, let's do this, we'll call this squares 1. And now variable names have to start with a letter or an underscore. And what we'll do is you will camel case. So you'll say, hey, start with a lowercase, and then if you have more than one word, you'll do an uppercase. So like squares 1, int squares 2, 2, int squares 3, 3, I don't know, sure, something like that. This is a little silly here, but we have the name, and then every next word gets uppercase, because you can't have spaces. You can't have spaces in variable names. Java says they have to be all one word with no spaces, essentially. So start with lowercase, and then every next word gets an uppercase. Okay? So if you want to do some arithmetic, we would take squares 1, and we can change the value of it now. We can say it equals squares 1 times squares 1. This one looks really silly, but what we get is we're going to do everything on the right first, and then assign it to the left. The capitalization, Java is case sensitive. It doesn't care how you do it, but the general accepted style or formatting style is this camel casing. So where every next word gets a capital letter, because it makes it easier to see where the next word starts. So if you have a really long variable name, like you might have a string for my full name, right? That's probably better, Eric Chernesky. Right, just take a look at how different that looks versus my full name. Just trying to read the variable name when you see it. My full name or my full name. Yep. So this is called camel casing. Each next word is a capital letter. Okay? It's just easier to read. It's easier on the eyes. Again, Java could care less. I could say string A is Eric Chernesky. Java's fine with that. I'm not cool with that. Other developers are not cool with that. Right? Use a good, meaningful variable name. Variable names are picked by the programmers. They're programmer-defined identifiers. So we're going to pick nice, meaningful names. Okay? So you want to know what the variable is just by looking at the name of it. So this example here, squares 1 times squares 1, Java will say, hey, go get me the value of squares 1, multiply by the value of squares 1, and then assign it. So you get the stuff on the right. Stuff on the right happens before the assignment to the left. So everything on the right will happen before this assignment to the left. So 1 times 1 is really boring here, but sure, we could do squares 2. Squares, not 3, 2 is squares 2. I'm just up, down, and then I'm tabbing here because I don't want to do a lot of typing. So 1 times 1 is assigned back to 1. 2 times 2 is 4, assigned back here. Yeah, kind of backwards a little bit. So the stuff on the right happens, and then the assignment to the left. Okay, letters are okay. Numbers are okay. So you kind of have 1 here, but you can't start with a number. It has to start with a character, or technically the underscore, which is kind of funny here. But that's okay. A hat, you got it, my friend. Let's rep the chess bros here. The OG chess streamers. I'm still trying to get that, what is it, an affiliate link? So, so they can fund the scholarship fund. So strings are just a bunch of text here, Mr. Vicky. Ints are integers or whole numbers. Undeck, you got it, my friend. You got it. So I noticed back when we were in person in classes, I would still tell all sorts of dad jokes because they're my favorite, and people would laugh all the time. And remember that semester that got interrupted when COVID started? I don't know if you were students back then or not, but we were in the middle of winter semester, and we were in person, and then all of a sudden the pandemic hit, got to Michigan, and we said, oh, we need to shut down and stop meeting in person, and we went remote. Everybody stopped laughing at my jokes. Turns out they're not remotely funny. Yep, so there are a couple different types in Java. So integers for whole numbers, strings for text. There's also a type called a char, which is a single character. Char for character. So this is just a letter here, or maybe we'll call this initial. Initial first name. No, first name initial. How about that? First name initial. Initial equals E. And now characters get these single quotes. So char characters in single quotes. So squares 2 it's kind of a silly name for it here. So it said squares 2 equals squares 2 times squares 2. So we're going to take the current value, which is 2, multiply 2 times 2, and then squares 2 will now be 4. We're going to replace the value of 2 and overwrite it with the value of 4. So you can change the value of variables here. They're variable, they can change. Kind of how we got the name variable. So the value being stored can change. They don't have to be stuck to whatever it happens to be. Yep. So again, this is not. I wouldn't recommend actually using this kind of approach here, right? We don't need to bother with that sort of approach, but we can, right? Just showing you can change these values here. So lots of different types. You also have doubles. So double is the next common type we're going to use. A double is a number with a decimal place. Okay, so number with a decimal place. And doubles can store really big. They are twice as big? Twice as big? I think it's twice as big. Oh, I don't need chess. Sorry, I didn't close that soon enough. Let's see. I'm just going to go Google it here because I don't remember. Let's bring this back up. So let's do... Nope, come on. Come on. Go big. There we go. So Java size of double. We'll see what we get. Aha! 8 bytes. So 64 bits. So it uses 8 bytes to store a double here. And let's see, how big of a number can you get when you get to 8 bits? Let's see. There's actually double. So let's pick. Hey, so cool. Thanks for following, AirDud. Let's pick a number here. How about we say pi approximate? Because we're not going to do actually the value of pi, but we'll say like 3.1415926 something. I forget. I think that's about as far as I remember. Which I think this is what, 8 significant digits? 1, 2, 3, 4, 5, 6. Oh, it's 7 significant digits. You can get to the moon with this without offshooting with 7 significant digits of pi. Turns out, I was blown away when I learned that. Like how accurate pi needs to be for NASA is not all that accurate for rocket science. Isn't that crazy? Super crazy, right? Okay, I thought it was interesting. Maybe you didn't. So now we'll store a number with a decimal place. And we can print out our pi approximate. Here. Okay, and then if I wanted to say, here's a circle here, so I'm going to say a double for circle radius, right, we'll say, I don't know, how about a circle with a radius of 4? And we can print the... What do we want? We want the circumference of a circle. Circle with a radius of, and I'll just go down the line here. We'll add in the circle radius is, and then I will do my pi approximate times the circle radius times 2, right? Pi d for circumference. D diameter is 2 times the radius. We can do all that arithmetic right in here if we wanted. Right? Does that check out? So 4 times 2 is 8. 8 times pi, a little more than 24. That sounds right. So you could do this here, or we could have another variable name. right? We could also have a double for circle circumference. Circumference is, and we can just use this math here, and I'll replace it. I'm just copy pasting here. Control X for cut. Control V for paste. Control C for copy. Semicolon. That's why I was mad. Those red lines here. So sometimes that little helpful hint here says, oh, I missed the light bulb. Where is it? Where is it? Give me the light bulb. There's the light bulb. It says semicolons expected. Oh, that light bulb is not helpful. Replace explicit type with var. No, that's not a helpful hint. It's just the red line it's missing a semicolon. Right, semicolon expected. Sure. So same thing here. So you can do the same thing. You can make a variable. They're free, essentially. Again, it takes up a couple bytes, but we have billions of them, so we don't care. We're pretty spoiled when it comes to computing nowadays. Years and years and years ago, when they didn't have as much memory, we couldn't be as spoiled. But we don't care. It's not our problem anymore. All right, we could do that, and then we could also do an area, right? So area, or what, circle area? Sure, circle area is pi r squared, right? So my pi approximate times the radius, circle radius, times the circle radius. Right, pi r squared. Squared is just a number times itself. Oh, not the circumference. Oh my goodness, circle radius. Radius. That'd have been wrong. Right, and then we could also print then if we wanted to, right? So we'll say, I don't know, plus, and the area is, oops, end the quote, add that in as a variable here. What do we get? That's getting a little long, so how about we do a new line then, right? We'll add in our own \n for a new line. Run that, give it a little format. Okay, circumference of a circle with radius of 4 is 25 point da 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 da. The area is 50 point da 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 da. Sounds about right. 16 times pi, right? 16 3 times 48 plus the little bit of extra here. Sounds pretty close. And then what I can do is I can just change the value of radius. We can say, hey, let's go to 6 and run it. There we go. Awesome. You're okay with that? So again, the only thing I'm changing is this value here. Or we could do it again if we wanted to, right? We could recalculate, do all those sorts of things. Sure. Put it back to 4. Why not? And run it. Okay, so we can do arithmetic here with our variables. Excuse me. We all right so far? Oh, it's 7 o'clock. I've been talking for a while. Why don't we take a little bit of a break here? And then we'll come back and pick it up where we left off here in chapter 2, okay? All right, so we put some music back on. Here we go. So we'll come back about 10 minutes or so. So let's do 7:13, 7:14. Yeah, 10-minute break. All right, so go get some beverages, get some coffee if you want it, something else, and we'll come back in a little bit. All right, see you folks in a little bit.
In when I show up, whole place about to blow up. Superior to that competition. I'm in first place, so that's how I'm living. I'm winning till they digging up my grave. Eating all the things up on my plate. Game face when I step up into place. was born and when I watched me elevate. I was born and when I watched me elevate. I don't know what to say, I don't know what to say, I don't know what to do. Colors all around, but I don't see anything but blue. Get lost in the sound, go back to the start. Let's go out of the dark. Let's go out of the dark. Get into the light now.
Yeah, I've been running and running to keep it 100. It's all that I wanted, but lately I don't get the stomach. The higher the summit, the harder the plummet. They know me all over this planet. I'm just a man and I can't understand it. Proud that I win and I did it myself. Probably wouldn't if I got the help. Hearing subliminals all on myself. Feel like I'm breaking, I'm falling to hell. Told me I'm sick and I tell her, oh well. Rather be dead than to know that I failed. Live for the chase, life is a race. I'm out of space, I'ma get on my face. I got a taste, well the whole plate. Finna get laced if you step out of place. Like, first off, you don't run nothing. All talking, your team bluffing. My squad, we all dream crushing. We ain't rushing, no discussion. All I know is us made for this. Paid for this, yeah, slave for this. Been down and I'ma get it right. Get on sight like. Been down and I'ma get it right. Get on sight like. And I'ma get it right, dead on sight like. Never really know when you're gonna go. Why you gotta put another foot in front of yours? Bury them toes, carry them close. I was never one to care about my mentos. I was like froze, now I'm on floor. Give me that smoke, but I can't get high. We do the most. talking, your team bluffing. My squad, we all dream crushing. We ain't rushing, no discussion. All I know is I was made for this, paid for this, yeah, slave for this. Been down and I'ma get it right, dead on sight like. First off, you don't run nothing. All talking, your team bluffing. My squad, we all dream crushing. We ain't rushing, no discussion. All I know is I was made for this, paid for this, yeah, slave for this. Been down and I'ma get it right, dead on sight like. Been down and I'ma get it right, dead on sight like. Been down and I'ma get it right, dead on sight like.
At Kroger, everything we sell is guaranteed fresher than fresh because our associates constantly check to make sure everything is at the peak of freshness. That means peeking at the peaches, spying on the steaks, and delving deep into the dairy department. So everything we sell is guaranteed fresh or we'll make it right. Kroger, fresh for everyone.
Get more ways to save at the Buy 5 or More Save $1 each sale. Just buy 5 or more participating items and save $1 each with card. Kroger, fresh for everyone.
I absolutely love my dog, but the constant shedding, not so much. But then I got a Swiffer Sweeper pet kit, and it is amazing. These super thick cloths pick up a crazy amount of hair. Just look at all that. And that was just from one swipe. And the best part? Sweeper's so much easier to maneuver than a broom or a vacuum, easily getting around chairs and under the couch. You're right. Now I can focus on you, not your shedding. Swiffer Sweeper Pet Kit, because shed happens.
You've had the idea for months now. You've told your friends about it, your mom, your mom's mom, your yoga instructor. You've worked out every detail, the name, the logo. Now it's time to Squarespace it. But you don't know a thing about websites? Squarespace it. Worried about it looking good? That's what templates are for. Squarespace it. But you need more than a site? Need a whole brand, social campaigns, promotion, the whole 9 yards? Squarespace it. It's that easy. Got an idea? Squarespace it. Use offer code Spotify for 10% off your first website.
It's the calm before the storm. Things aren't as they were before. You best start bracing. Did you think you could keep us out? Shut the gates, forget us now. Tides are changing. Can you hear the sound? Can't stop us now. We're not back in town, know what we're doing. Things are about to change, it's evolution. Voices shake the ground, you feel it moving. We're the revolution.
All right. Yeah, it should be in the link in the syllabus there, Beta. The NetBeans download, you can get the Mac version or the Windows version, whatever you need. Or you can use the virtual desktop. Hey, baby, you coming back? There you are. Hi. Oh, you're noisy. Hi, sweetie. Alrighty. Let's give that a little pause here. Cool. So we're back. Yeah, the link here in the syllabus should be fine for you. Or if you just Google NetBeans download, we'll grab that one here. It's the NetBeans IDE, netbeans.apache.org/download. I think that's the link I gave you here. You go to download, and we were using the Windows one. You'll just pick the Mac OS one. Yep. AUM-loco. You can't do links here in Twitch, unfortunately. I'm going to post it in the Discord, you can. Is that Dr. Baugh's video? Yep, that one ought to work for you. Awesome. Hey, baby. We got both kittens in here now. The other one's asleep over by my window. Right back. Nope, that one. That hand. Back there. All right, so some types here, right? So we have integer types, they store whole numbers. We have double types, they store numbers of the decimal place. And there's this really cool thing here. It's double dot max value here. Max value. We'll see what that maximum value is here. Because I don't actually remember. Because 8 bytes is pretty large. Ooh, E308? Holy cow, what's that? 308 decimal places? Or no. 308. Yeah, we've moved the decimal place 308 times. So what is a number with 308 zeros after it? I know millions and billions and trillions and quadrillions and centillions. Oh my goodness, that's big. 308? I don't even, that's a lot of zeros, right? 308 of these, right? So this is, I don't even know, right? Like, and that's not even, okay, that's 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42. Whew. Yeah. I thought a Google was 1,000 zeros. Is a Google 100 zeros? Just ask Jeff Bezos. Yeah, it's some large number, right? You know, he does not have this much money, though. As much money as he has, he does not come anywhere near this number. The highest float a number can handle looks like to the 38th. So if we say, what is float dot max value? Let's take a look at that. Max value of a float is only to the 38 zeros here. Yeah, floats are stupid. That's my short and simple version of it. Ow! Ow! Baby! Ow! That's my leg. Ouch! She still has some really sharp claws here. Sorry about that. All right. Clawing your way up my leg here hurts. So a floating point number is like a double, but half the size. It's only 4 bytes. Hey! Someone else is following. I missed the alert there. So floats are smaller. So if you don't need the size of a double, a float is smaller, will use less memory because it only uses 4 bytes instead of 8 bytes. So it is more memory efficient. Most of the time we don't care. We could care less. Again, we're a little spoiled, and we're just in the intro class where we're not doing anything at scale that doing like millions of these operations, storing millions of these is going to matter. Because we're never going to store a million something. But float does exist. So if you want a float, smaller number with a decimal, how about like, I don't know, what do we want to store here that's smaller? How about 198.7? Right? And now it gives me a red line. This is the other reason I hate floats. Okay, Google's 10 to the 100. Okay, so 10 to the 100 numbers. Thanks for checking. I'm loco. So right now it's upset with me because it says incompatible types, possible lossy conversion from double to float. So by default, when you have a number with a decimal place, here, oh man, my sugar's a little low. I need to get a little snack here, sorry. It's the sad thing about being diabetic. But I have a pack of Swiss cake rolls here, never fear, that I will just eat in front of you on screen. If my sugar gets too low, I will pass out, and that would be really unfortunate. Nobody wants that. And it just makes you feel really yucky. Not fun at all. I'll put some music back on for a second. You don't want to have to hear me chew.
With a whisper in the trees, do you feel us watching? Hunger in our eyes, victories on our minds. It's our time to rise. Can you hear the sound? Can't stop us now. We're not back in town, know what we're doing. Things are about to change, it's evolution. Voices shake the ground, you feel it moving. With the revolution. Can you hear the sound? We're the revolution.
Alright, sorry about that. Little snack break there. Alrighty. You know, I would share with you, Studio. I showed you what it is. I don't think DoorDash will bring you Swiss cake rolls, but Instacart or Shipt might if you order enough, right? Alright, so anyway, right now, this is the other reason I hate floats, because I can't put 98.7 in, because Java thinks a number with a decimal place is probably a double. So if you want to tell Java that this is actually a float, you put the letter F here after your number to tell Java, yeah, I meant float. You can DoorDash Meyer? Okay. Huh. The amount of things you can get delivered is amazing. So you have to tell Java you want a floating point number with an F here. And that's why I just won't use them. So I will typically use integers for whole numbers, and I'll use doubles for numbers with decimal places, because again, I don't care if we're using 8 bytes versus 4. It just doesn't matter to us at this point. Later on, yes, at scale it does matter. And we could be specific about how large of a number we need, or how precise of a number that we need. But for now, we don't care. Floating points can have 7 digits of accuracy, 7 decimal places. Floating points can have 15 decimal places. Okay? That's a fun fact for you there. There's also numbers that are bigger than ints that are called longs. So a long number is really big. It takes 8 bytes. It can be positive or negative. That'll get you up to, oh, I don't even know, some large number there. And you could go smaller, you could go shorts, or you could even go bytes if you need to. So again, all about if you need to, great. We're just going to be lazy. We're going to use ints, we're going to use doubles, because they're easy for us. All right, a fun thing about integers here. Let's see. So if we wanted to say, I don't know what, let's just use some math here. Let's do like 10 divided by 3 equals, and let's do, we'll add in here, 10 divided by 3. This is division, right? That's our division operator here. What do you think we're going to get? What is 10 divided by 3? Is 10 divided by 3 3? Sure is in Java land. It is, in fact, in Java land 3. This is integer division. Integer division gives integer results. Right? If you take an integer divided by an integer, you're going to get an integer result. Integers don't have room for decimal places. So what happens is any decimal remainder just gets truncated, gone. You get an integer result. So 10 divided by 3 sure is 3 in Java land. Okay, you could also then do, I'm just going to copy paste because I'm lazy here. We'll just copy paste the whole line, right? Why not? If you have 10.0 here, 10.0 is a double. It does not round at all. It truncates or chops the decimal off. Yep. So 10.0 divided by 3 is a double. A double divided by an integer does not give you integer division. Divided by integer or int divided by a double is a double result. Right, so if one of the two operands is a double, you'll get a double result. Yep, 11 divided by 3 sure is. Yep. No rounding happens. No rounding. Truncation of the decimal. Decimal. There we go. Mal. M-A-L. Right? Still 3. But if one of your two operands is a double, you'll get a double result. We get 15 decimal places here, right? And weirdly, it says 5, which, you know, if I remember back to my math class, is not correct. 3 doesn't even round to 5. So Java, at least the primitive types here, primitive types are the types that are built into Java, like double and float and int and char. Those are primitive types. A string actually is not a primitive type. String is actually a class built into the Java library, which is really cool. My leg really hurts where she climbed up. It's only bleeding a little bit. That sweet little kid. Oh, now she's cuddling with her brother. Both cuddling over by the window. Right over there. You just can't see, sorry. Behind my shoulder? Nope, not high enough. Oh, I'm going the wrong direction. Nope, not there. Yeah, I'm getting a little shaky here. My sugar's low. It's going to be a minute till it comes back up. That's unfortunate. Alright, so be careful with your integer division. That's my phone alert saying my blood sugar is low. Yep, sure is. Thank you, folks, for posting pictures of your pets there in the pets channel in Discord. It's fantastic. All right, other types in Java. There's a type called a Boolean. A Boolean is really funny. Boolean is true or false, on or off. Remember we talked about bits in computer land? When we store things as on or off, as 0 or 1, those are bits. A Boolean is a bit. It's on or off. So this is true or false. And it either equals true or false. And that's probably a bad name for it here. So Eric likes jokes. We'll say the value of that we're going to assign is true. So that's Boolean, it's true. Okay, we had chars as well. You know, a fun fact about chars here. So I did my first initial here. We'll do last name initial. That's the character C here. Okay, and I did a capital C. Lowercase c is different as well. You can print out a single last name initial here like that, if we wanted. It'll print out the letter C. Now, what if we wanted to print out my first name initial? Oops, first name initial plus the last name initial. What do you think we're going to get? So plus is in, oh, that's not string concatenation. I got, isn't that funny? We'll do first name initial. It'll print out the last name initial. Oh, come on. There we go. Last name initial. And I try and concatenate them together, and it adds. Isn't that funny? So it turns out characters are stored in Java in 2 bytes in Unicode value. So Unicode characters are stored as 2 bytes Unicode value. So the Unicode value is back way long ago when we found out how we needed to store a character. Remember, we can only store zeros and ones. We can only store bits. All we get to store. So we needed a way to represent numbers. So if we just go Google that one here, let's look up Unicode code values. We'll look this one up here. And there are all sorts of Unicode values. Here, list of Unicode characters. Is this a good hit? Wikipedia is probably good. The basic Latin set, perhaps? That looks like it might be it. Yeah, here we go. So the decimal value, right, is what it's the numeric value that it's storing. So a decimal 32 is the space character. Sure. Here we go. We get numbers in here. We get characters. So the capital A is 65. A capital E is 69. A capital C is 67. So when I go add those together, what is 67 plus 69? 67 plus 69? 136. When you add 2 characters together, it's taking their Unicode value, which is a numeric value, and their numeric value and actually adds. We don't get character concatenation, we get character addition, which is their Unicode value here, behind the scenes. Which is kind of crazy. So this actually takes the value there, so that takes, what did I say, 67 for C, right, and 69 for E, plus 67 for C, right, and we get out that numeric value result. So you have to be careful with characters. Characters are a lot of fun, but they're actually stored as a numeric value, and then Java says, oh, it's a character, you want the character value, usually, but if you're trying to add two characters together, it doesn't concatenate. Right? It just adds. So do be careful with your characters. But they are really fun. Alright, other things about variables. Java lets you do all sorts of fun stuff. If you wanted to concatenate them and not add them together, you would want to treat them as strings, probably. Because a character is just a single character. You can't even have two characters together. So I think if we did plus, how about a string plus a string? How about that? That might work here. Let's try that. There we go. So a string plus a character will get you a string, and a string plus a character will get you a string. So but if you don't have that string there, so let's undo, or no, let's leave that there, and then I'll do it again here without. Okay, and put that down, so then if we string plus character gives you a string here. Okay, how's that? We can do it that way if you want it. Excuse me. All right, other cool things you can do, right? If you have more than one value at a time, so we might have char for, how about a middle name, initial, and then you could just comma separate and keep going. I'm not a fan of this at all, but if you wanted to, you could. How about, you know, hyphenated, last name, initial, right? You can declare more than one. So you can declare variables, and then later you can go assign them. So middle name would be a T here for my middle name, and then my wife has a hyphenated last name, so she would add in the S there for her hyphenated last name if she wanted, for her initials, which is fun. So instead of initials, she dropped her middle name, and she does first name, hyphenated last name for her initials now, when she initials things, and just dropped her middle name, middle initial. I thought was fun, instead of having 4 initials when you have like initial paperwork for things. So she does that, which is fun. So you could do that. So this is declaring multiple variables of the same type. I put a semicolon. I'm so used to semicolons. You can do it that way, and this is assigning or initializing the value. Hey, thanks for following. I missed who it was. Sorry. That alert only stays for a few seconds. Super Pog. Oh, so glad to have you along, Rusty. I take it you're not part of the 1500 class at OCC that is following here because they paid to. All right, cool. So again, I'm not a fan of this, but you're welcome to do it if you want. I don't like it, so I would rather have everything on its own line, like we did. Double, double, double. Each gets its own line. That's okay. Oh, no, that's all right, Rusty. Glad to have you along. So if you wanted to, you could declare and initialize on the same line, right? Like T here, and then comma, and initialize another, and that is also ugly, and I'm not a fan of that either. So I'm just going to ignore that and pretend that that didn't happen. But Mr. Gaddis shows you can do it if you follow along in the text. Okay, so you can declare. So a variable can only have one value at a time. We can go change it later if we wanted. Right, so we could change that favorite number. We could say, hey, favorite number, let's now equal, say, I don't know, how about 101? This changes the value of favorite number. So we could print favorite number, and then I'll copy this, and we'll print it again after we change the value. Remember, this is the assignment operator. We're saying, hey, 101, now store yourself in wherever favorite number is. We'll get the old value, and then we'll get the new value. But favorite number is only ever going to have one value at a time. Okay? So we've done arithmetic, right? We've done addition, you can do subtraction, you can do multiplication, we've done division. There's also another operator which is super cool. One of my favorite operators is called modulus. So remember back to, is it 3rd grade math, when you start learning long division, how you have a remainder when you do long division? Modulus gives you the remainder. So if I were to take a number, I'll have, I don't know, first number is, give me a number. Somebody in chat shout out a number for me. I'll have a first number and a second number. Just shout out some numbers. I'll plug them in here. 34 is our first number, and 8 is our next number. Sure, I like it. We'll give it a little format. So we'll say that first number divided by, we need a plus in here, right? Divided by the second number. Second number is plus equal to, space there. And we'll add in first number divided, no, first number divided by the second number. So I'm just going to bump this down a line here, right? Just because I'm running off the edge of my page here. Remember, when we do integer division, we're going to lose that remainder. So that should be 4, right? But what happened to the remainder? Right? Well, the remainder is remainder, there we go, of, and now in here we want to say first number modulus the second number. Modulus gives you the integer remainder. This is modulus, integer remainder. So we can do 3rd grade math with our modulus operator here, remainder 2. So if we want the integer result, we can do integer division, and then we can get an integer remainder with the modulus. If you want it to be a decimal, well, then you want to make sure one of the operands is a double. It just depends what you want. Okay? Here's another one for you, and this drives me absolutely insane. When this stuff goes around on Facebook, and I know I'm old and I use Facebook, and none of you cool kids do that at all. You probably use Instagram or Snapchat or TikTok now, right? Whatever new thing cool kids are using. But still, this sort of stuff gets shared around lots of places. They'll say, hey, what is, and we'll do, say, I don't know, what, like 9 plus 5, no, how about 4 divided by 2 plus 3, or something like this, right? And they'll say, hey, what is it? Now, this one's easy, right? Because you know your order of operations. Hey, Biggie, right? We know we do the division first, and then we do our arithmetic. So 9 plus 2 plus 3 is 11, should be 14, right? No problem there. Should be 14, easy peasy, right? That's the easy one. Now, what happens if we get one of these harder ones here? And they say, hey, how about we do parenthesis 4 here? What do we get? Now, we can't just put parentheses 4 here in Java land, because that is 2 times 4. Remember, parentheses, if your number's touching a number in parentheses, it's implicit multiplication, but it just means there's a multiplication sign here, right? Now, what do we get? What is 4 divided by 2 times 4? Now, a lot of you will remember back to math class, and you had someone tell you this thing called Pemdas. Parentheses, exponents, multiplication, division, addition, subtraction. I mean, like, usually it would be like, instead of 4, it'd be x, right? Like 2x, like, that's implicit. It's not, it really means 2 times x, right? So if we had 2x and we said x equals 4, right? That's like saying times 4, right? Like, think your algebra, right? We do implicit multiplication in algebra all the time, right? So when we get this problem here, now what people do that drives me crazy is they say, oh, Pemdas says parentheses, exponents, multiplication. I need to do my multiplication first. What is 2 times 4? That's 8. Okay, division. What is 4 divided by 8? Well, it's half. And they say, okay, 9 plus half plus 3. That is wrong, my friends. That is so wrong. Multiplication and division have the same order of precedence. So we do them from left to right. So we do 4 divided by 2 times 4. So 4 divided by 2 is 2, times 4 is 8. 9 plus 8 plus 3, 20. Java knows how to do this. Okay, Java's not dumb. Uh-oh. 983. I did a bad thing. I confused it. Oh, I didn't run the first one and actually check it the first time. Here we go. So it sees a string, and then it sees a number, and it's concatenating it together. And then it sees some arithmetic, does the arithmetic, concatenates it with a string, sees another integer, concatenates it with a string. My goodness. So parentheses here, friends. Parentheses will tell Java, please do the arithmetic. There we go. Thought it was crazy for a minute there. 20. Okay, it is not 12 and a half. Same thing with addition and subtraction. Right, it happens, they have the same order of precedence. They happen from left to right. So be careful, right? Don't assume things will happen. Use your parentheses. If you want 2 times 4 to happen first, do 2 times 4. Right? Put it in parentheses to force it first. I'm a big fan of parentheses, even if they're redundant, because it makes it really clear what we wanted to do here. Okay? So that is our order of operations. And modulus has the same level of precedence as multiplication and division, because it's a division operation, but instead of giving you the result, it gives you the remainder. There's a divisor and a dividend and a quotient, right? Instead of giving you the quotient, it gives you the remainder. Is that the right math terms? Man, my kid's been doing too much math here at home. I should not know those terms. Should not know those terms. All right, you okay so far? We are just cruising through this. Those did sound like math words, you're right. Yeah, my 13-year-old still gets confused with long division. Just the writing it long versus writing with long division, and what goes inside the little archy thing and what does not. Sticks, I never promised to know math. I never promised that. Right, what's the whiteboard? Here we go. Right, he still gets confused a lot. Here on, clear this off. Like if you say 12 divided by 3, it's 12, like 3. And it always says it backwards. Yeah, they used to promise you'd never carry a calculator in your pocket all the time, right? Why would you depend on a calculator? Because you'd never always have one with you. That is a lie. But, sure. All right. So do be careful. Do be careful. The biggie, basic addition, and that's it. Yeah, that's okay. That's all right. Just make sure you know how to use your calculator. All right, so if we were to have some ints, we had first number, we had second number, we might say, well, a result is first number plus second number. All right, we could do that. So now we have a new result. Now if we wanted to add 10 to result, we could say int result equals result plus 10. Right, take the value of result, add 10 to it. Oops, it's upset that I'm saying int again. So once you have told Java you want a variable of a given type here, you don't need to tell it the type again. We just say, hey, result is result plus 10. So take the result, add 10 to it, and then assign it back to result. Now, this is a lot of typing here. So the shortcut for this, for us lazy programmers, we'll say result plus equals 10 here. Oh, goodness. I get some followers? Yeah. Thank you. All right, band. I love throwing out that band hammer. So result plus equals 10. So plus equals is the same thing as saying take my result, take my value, add something to it, and then assign it back. It's a shortcut. It's the combined assignment operator. Assignment operator, right? You assign and you operate. You take an operator and you assign at the same time. Right? A little shortcut here for us lazy folks. And you can do it with addition, subtraction, multiplication, division, and modulus if you so care to. It's fantastic. All right, we okay so far? You folks are doing great. We are cruising tonight. Just pausing for any questions here. A math class would be a little tricky if you can't count, for sure. Yeah, we do require, I think up through statistics, right? Or finite mathematics, I want to say. Hydration, I'm out. I have to go get more. My coffee pot is empty. My ice is empty. I'm in trouble here. I used to have a pack of Perrier. I don't see it. I'll owe you a hydration, Biggie. I'll go get one at break, okay? Apologies for that. Yes, the statistics class is probably the most useful math class you'll take. Calculus is interesting, but in many cases not as practical, for sure. But super interesting. I'm glad I went back and took it. Yeah, for a traditional computer science degree, for anybody who's like accredited, you're going to take Calc 1, you're going to take Calc 2, you're going to take linear algebra as well. And then you're probably taking discrete mathematics as well. It's a very computer-focused math. So you do a decent amount of math. Calc 2 is the hardest, though. Linear algebra is relatively easy, and discrete mathematics is easy as well. Calc 2 is the hardest. I had to take that one twice. But it's a little harder to memorize things in my 30s than it was when I was younger. So trying to memorize all those trig identities and formulas and things just didn't happen. So that was unfortunate. Yes, you can use the calculator for sure, but you need to know how to use the calculator, and that's the tricky part. And if you're looking for a good math tutor, our Academic Sports Center has some good ones. You might be familiar with one, Mr. Tim. Calc 4. I've never heard of Calc 4. Is that differential equations undecked? DiffEq? You'll take like differential calculus, integral calculus, multivariable calculus, and then DiffEq. I guess it's not usually called. I haven't seen it called Calc 4 before, but that's interesting. Linear and differential equations. Oh, that's fun. They do both at once. I thought they were separate classes. So I know we offer linear algebra and we offer differential equations and we offer calculus 3. Definitely take your math classes at the community college and just transfer your C or better grade for credit, not for GPA. Yep. Yeah, because a lot of companies, if they're looking to hire interns, want to see your GPA and say they want like a 3.0 or better sort of thing. Sticks, no, but they've sold like 7 different editions of books since then. And they'll charge you up the nose for that new edition of calculus that's been the same since it was around for a long time now. Quite a long time, right? Was that Newton? Was he calculus? Was he the one that we were saying, hey, when he was quarantined for the Black Plague, he invented calculus or something? I forget. So a fun fact, I have my laptop and I have my second monitor, so I keep looking up. That's where chat is on the second monitor. The monitor stand, the piece that goes up and down, wasn't tall enough to get it above the laptop screen. So I needed like an extra 2 inches. And I was like, oh, hey, it's pretty wide and large. Like, I couldn't just take a small thing. It's like, oh, my calculus book will fit. So I've got my calculus book underneath the monitor there. Yeah, math in person is probably a little easier. I'll definitely be able to ask questions and things like that for sure. Yep. Yeah, definitely at OCC. Do we still have the math lab, Tim? Do you know? Do they have the dedicated walk-in tutoring hours for math, or did that kind of get absorbed with the Academic Support Center? I haven't been on campus since I started full-time, which is super weird, but that's okay. Back when I took my calculus just a couple years ago, they had a dedicated math lab with math tutors. It was awesome. You could just walk in and they could help you with any of the homework problems you were stuck on. I spent 15 minutes on one because my arithmetic was bad. It was so dumb. Maybe I should have used the calculator. Yeah, once we have face-to-face. Since we're on a tangent, oh yeah, tangents are good. So the plan that I've heard so far is, depending on CDC guidelines on distancing for people indoors, if we can get to 3 feet or less of distancing being considered safe enough, we'll probably be in person for classes. If we can't get closer than that, then we just can't get enough physical people in a classroom. We're not going to run classes with 10 people because that just loses too much money, unfortunately. We'll just stay remote. But it's looking like, especially with all the new guidelines and things for vaccinated adults and safety that way, that we're all fine indoors, right, with other vaccinated people. And it'll probably be fine, but there's no vaccine mandate currently. So I don't really know how we're going to handle folks who aren't vaccinated. But as long as there's not many of them, it should be safe as much. And so some of the classes on Loco are remote classes. Depends on which class. There's this whole big, long process I'm finding out of what you have to do to get a class approved to be taught online. So some of them are. One of our programs in CIS, the Business Systems Analysis program, should be fully online, best I can tell. All the courses are available to be taken fully remote online, like offered during regular scheduling. And then we're looking at bringing the software engineering program online next. But that involves lots of work for myself, Dr. Baugh, and the new full-time faculty member we just hired. Because the database class is already online, the networking class is already online, so it's like some of those intro-level ones are already online, but nothing else in the software engineering track is. So I have to develop some, Dr. Baugh has to develop some, and we're going to try and talk the new guy into developing some as well, and see how well that goes for our software engineering program. But that's the goal, but it's going to take quite a while. Things move ridiculously slow in academia, I'm finding out. So, yeah, unfortunately, we'll be back to face-to-face. As long as I've got the flexibility, the plan for my courses will be basically the same thing, but I will teach and broadcast on Twitch from the classroom, so that if people want to be taking it remotely, that'll be an option for them. But it won't be an official remote class because we can meet in person in the lab, which is awesome. Hey, I'm Loco. We do hire instructional designers every now and then. I don't know if there's any current openings right now, but we do have 2 or 3 of them, I want to say, in our Office of Online Learning, or what do we call it? I forget. There's a name for the department. I forget what it's called. And they'll work with people as we bring classes online to make sure they meet all the requirements. There's a whole bunch of other things we have to do to meet, which is really interesting. Yeah, I'm trying to look at changes to the software engineering program, and if I propose them now, they won't take effect until 2022, the fall of 2022. So that's 16 months out now for a change I want to make. My goodness. So, yeah. All right, awesome. That was a good sidetrack. Thanks. Always fun. So let's look at another feature here in Java. Is another reserved keyword here. So you saw I had this cool thing called pi approximate. Where do we put that? Right here. A double for pi approximate. Now, this is great, but I'm probably never going to change the value of pi approximate. So if it's going to be a constant value, I can use a keyword to tell Java, hey, don't let me change this. Right? Protect me from shooting myself in the foot and doing a dumb thing here with the final keyword. So you say double final here. And, oh my goodness, what am I doing wrong here? Nope, it's on the wrong side, sorry. Final double. So I always have to look it up. So final double means this will not change. I'm going to assign it once, and then I can't change the value again. So if I try and go to pi approximate and give it a new value, like 22/7, right, it's going to yell at me and say, can't assign a value to a final variable. No good. So it keeps you from accidentally changing it, which is great, because a lot of times we're going to have a value that we're just going to use lots of places here. And then what we do, this is, we'll call it a constant value. Well, we're going to change the look here. So we change the way that we write these variables. We don't use camel casing anymore. To mark that it's special in our code, we use all uppercase here. approximate. And because you can't do, like, if you just run all the letters together here, it's really hard to know where the next word starts. Use underscores to separate instead of doing the camel casing where every next word gets a capital. Okay, so this is a constant. That value can't be changed. And now I need to go replace pi approximate everywhere, so I'm just copy pasting. Okay? So this is a final. So finals are fantastic. They're great. And the other really good thing is, you know, I don't actually want to have to type in 3.1415926 every time I want to use it. Because the more often you type a number, the more likely you are to typo it and screw it up. Right? So we want to use a value here. There's this idea that in our code, you probably never want to have just a number that it's not been assigned to a variable name. So, like right here, this 2, that's probably bad. Again, not in this case, it's okay because we understand how that works. Probably not the worst thing in the world, but we call them magic numbers. So if you just are like multiplying by some magic number for whatever your formula happens to be, and you've not declared it, you have no context. You don't know why this is a 2 here unless you understand, oh, it's the circumference formula. So giving a name to a value gives you some context. It's super useful, right? And again, the code's for people. We want the code to be understandable. Okay? So we'll use constants all the time that we need to have values for things. Mr. Gaddis goes into an example of a sales tax rate. The other great thing is if that sales tax rate ever changes, right? And our tax rates change all the time. Not necessarily our sales tax, but federal income tax changes all the time. If you have a constant value for it, you just change it once in your program. I would come up here, find where I declared it, and say, oh, okay, it's the next year. Now my sales tax rate or my income tax rate is another value. I change it one place, and it's automatically changed everywhere else in your program because you're using the name of it. So it lets you change one place, which is fantastic. Okay, so strings then, moving on to the next one, strings. We've done a couple strings already. Strings are amazing. They are not a primitive type. So remember, like ints and doubles and floats and bits or booleans and bytes and whatever. Those are primitive types. They store values. String is an object or a class that is built into the Java library. We can do all sorts of cool things with strings. So if you wanted to know how many characters are in Eric Chernesky, right? So the number of characters in Eric Chernesky is, and we should maybe put that like in single quotes or something here. You would say, what is that? Name was my variable name that had my name in it, and you could say dot length. So name is the variable name, and you can say dot. And if you put a dot there, it's giving you access to all the things that the string class can do. Name dot, come on. It can do all sorts of really cool things. And we're going to spend a bunch of time looking at strings later, looking at all the things strings can do. But one of the cool things they can do is give you the length. Tell you how many characters are in that string. So my last name is 9 letters, my first name is 4 letters long, plus the space, because the space is a character. We're going to get 10 plus 4, or 9 plus 3, 9 plus 4 plus 1, right, 10 plus 4, 14 characters in Eric Chernesky, because the space is also a character. Okay? So length is really cool. It can tell you how long a value is. And strings, a funny thing about strings is when you ask Java to go store some memory for a string, what it's actually storing in that string is the memory address of where it's going to be stored in memory. So if I just say string another name, like that, I'm going to declare a variable. So this declares string variable. It tells Java, hey, go out and save me some space to store a memory address. Space the size of a memory address. Then when we say other name equals, we're going to assign to it, right? Assign it the value of, let's throw someone else's name in here. How about we put in, let's do John. We'll do John Ball, Dr. Ball. Now it's going to go and allocate memory. So it gets memory to store John Ball and stores the memory address of that in the another name variable. I know that sounds really funny, all right, but what's happening, right, is we need we have all this memory out here, and it's all in hexadecimal, like 0732FB or something like that. I don't know. A bunch of hexadecimal numbers. There's a memory address. Okay? And each character in the string is going to take up 2 bytes. Right? So I need enough space to store the length of John Baugh. That's 4 plus 1 plus 5. So I need 10 characters, which will be 20 bytes. So I need that much space in memory here. And I'll store the J for 2 bytes, the O for 2 bytes, H for 2 bytes, N for 2 bytes. It looks the same. A space for 2 bytes, B for 2 bytes, and on and on and on down. E, A, U, G, H. John Baugh. So we're storing this here in 20 bytes, right? Each of these is 2 bytes. 2 bytes, 2 bytes, 2 bytes, 2 bytes, on and on and on and on and on. What is stored in another name is this value right here. This memory address is what we're storing. The memory address is where we're storing this information. So if you want to go change a string variable, it can't just change it in place. I can't just erase what's here and put new stuff in or make something longer. It has to go and get a new memory address, like x073, I don't know, 9f2 or something. I don't know. I'm just making up numbers here. It's a different one here. Okay? And then we'll say, okay, you don't point here anymore. Forget that. You point here, and we're going to store a new address. And maybe we'll store Ian Leith. Mr. Leith, another fantastic instructor here at the Orchard Ridge campus. Okay? And again, this takes up, so his name is 3 plus 5 plus the space here. That needs 9 times 2 bytes. So that only needs 18 bytes. Right? So strings are immutable. You can't change them in memory. So once you write the string in memory, it's stuck there. If you want to change it, it just makes a new one in memory, and you put a new thing there. So the actual variable is just storing where to go find it. So if we do another name equals Ian Leith, right? So it creates its memory store Ian Leith and updates the another name to store that address, wherever that address happened to be. It asks Java for it, Java asks the operating system says, here's some memory, go for it, have at it, have some fun. Gives you the string. Okay, so it's called a reference. So this references that object. So what's fun then, you can do another, we could say string more names. I don't know, more name. Sure. If we said equals another name, what we have now is we have 2 variables referencing the same location in memory. So because strings are immutable, I can't actually change that here. So where if I go and change, then we'll say another name. We'll change more name. Well, Bob. And we'll print out another name. And then we'll print out more name. That's a terrible variable name, I'm sorry. More name. So it's not going to change another name. Another name will still be Ian because you can't change this string in memory. It just says more name, go point at a new location in memory because strings are immutable. You can't change them. So we get Ian Leith and we get Bob. But integers are not immutable. So if I have an int, I don't know, we had a bunch of numbers, right? We can print out the first number, right? And then we'll say, how about, I don't know, int for more number. Sure, is first number. So if I say more number equals first number, and then I want to take more number plus equals 10, and then we'll print out more number, and we'll print out first number. More number gets added. So this one doesn't create 2 variables pointed to the same location, because these are primitive types. With a primitive type, you get a copy. You're getting a copy of the first number, 34. We're adding 10 to it. We're printing it out. So when I had, we had another name pointed here at Ian Leith, and then we said, hey, we had more name points here too, because we said it equals another name. It points to the same location in memory. When we had integers, the integer is still stored somewhere in memory, like x2, 3, 4, f. stored 42 or whatever, right? So this was a first number or something. First number. When we said another number, more number, it doesn't point here. What it does, it makes a new location in memory, I don't know, x37f2, and it assigns it again. We get a copy. So there's a difference between the primitive types and the reference types or objects. And we'll get more into that later as we go. So just be careful on how these, like if you're trying to assign two strings, you should be fine because you can't actually change them. If you're trying to assign from integers, you're okay. You're not going to run into too much trouble here. Okay? And scope. So scope is defined by these curly braces. I don't need to know too much about it right now. So if you can use a variable inside its scope. So if you declare a variable inside the curly braces, you can use it inside the curly braces. You can use more curly braces if you want and do really confusing things, and I don't recommend it. It's not worth any trouble here. Okay, we'll get more into that later. We looked at comments. There's really cool commenting called Javadoc Comments. I'm not going to ask you to do it. I trust you can go look it up if you need to use Javadoc Comments. They give some really cool documentation, and the Java API. If you just go Google Java API, there's a whole website here. Here's the Java 8 documentation from Oracle. This is fantastic. And our version 16 is essentially their version 8. I don't know why the versioning numbers are different, but the open source community went with a different version here. We can go look up any sort of thing here. So if we want to find string, we're going to search for string. Oh goodness, we got to search a little bit. Here we go, string. This is the string documentation. So this sort of style here is actually generated with Javadoc. It's really cool. You can do all sorts of amazing things with it. Again, we're not going to bother. But it says, okay, these are all the things we can do with string. These are ways you can construct strings. These are methods of string. You can say char at, you can say code point at, code point before, code point count, on and on and on and on. Anything you want to do with string tells you how to do it here. And it gives you examples, which is super cool, of all of them. So the Java API is fantastic for doing anything in Java. It's actually loaded, most of it loaded kind of by default in NetBeans. Like when we hit dot, we got all those methods. So we didn't need to go look it up. But if you're not sure how it even works, you can go look up all these, like what is code point at? Turns the character Unicode point at a specific index. Sure. We can do some fun stuff with it. That's the Java documentation. So if you write Javadoc comments with a particular formatting and style, on this, we actually started with one. We made a new project. And just make a new one here. Finish. I'll throw this one away later, but that's fine. You'll see here, these are Javadoc comments. / starts a Javadoc comment. So this one is a Javadoc comment. It says, hey, the author is me. This one says, hey, I've got parameters. Again, I trust you can go look that sort of stuff up. I don't care about any of that. I care if you can code right now, so I'm going to do it, delete that. But it tries to start you off with some. Let's delete it. All right, so we go commit what we have here so far. This is chapter 2. Examples. I'm going to commit and push. Okay, we're almost done. We got a little bit more to go here. You folks are doing great. We'll go a little more. Okay. So why don't we take one more break, and then we'll come back, and then we'll finish up chapter 2, and then we'll talk about project number 1. Does that sound like a good plan? So we got, it's going to be a little bit longer here with what we need to get to from chapter 2. Probably another 20 minutes, maybe. Let's say maybe half an hour. I'll try not to go too long. I know we're already getting a little bit late here, but let's try that. I'll put some more music back on. All right, awesome. So we'll pop back, say at 8:20. Okay, we'll come back at 8:20, and then we'll finish up another 20 minutes or so, talk about the project. Definitely be done before 9, okay? And that way we've got a little bit of time to practice afterwards, and then get a head start on the first homework assignment. All right, see you in 10 minutes.
I've been thinking, lately it's just me against the world. Round and round I'm caught up in this swirl, trying to dig and trying to burrow. Pressure turned this stone into a pearl. Lessons that I learned weren't always thorough, sugar-coated like a churl. Now I'm really out here on my own. Now my homies acting like I owe 'em, done extending out my arm. Made a lot of money from my poems. Been around and now they say I'm on. I can finally say I'm up now. I'm up now. 20,000 on a bus down. A bus down. I'm on my way up, going up now. Up now. And I ain't never gonna touch down. Touchdown. I ain't never gonna touch down. No, I ain't never gonna touch down. Mine's on, I can't turn it off. Late nights and I'm turning up. Hate life, then I learn to love. Down and out, now I'm way above. I always knew I had it, now I'm living out my dreams. Treat that money like an addict, it's a habit. I'm a fiend, feeling that rush. Rocket ready to launch. Hands up, ready and gone. Been waiting too long. Trust on plenty, that's wrong. Old me's dead and that's gone. Thank God I'm headstrong. I don't wanna wake up in a doubt that I show 'em everything I'm about. I ain't never going out. I ain't never did it for no clout. Now I'm sitting pretty on the ground. I say I'm up now. I'm up now. 20,000 on a bus down. A bus down. I'm on my way up, going up now. Up now. And I ain't never gonna touch down. Touchdown. I ain't never gonna touch down. No, I ain't never gonna touch down. I'm up now. 20,000 on a bus down. A bus down. I'm on my way up, going up now. Up now. And I ain't never gonna touch down. Touchdown, yeah.
I'm just calling to say I
We'll get back to your music shortly, but first, did you know that prescription prices are different at different pharmacies? You could literally drive across the street and get a different price. That's crazy. But with GoodRx, you can instantly compare prices at every pharmacy in your neighborhood and save up to 80%. You're probably thinking there's a catch, right? Nope. It's 100% free and can save you money whether you have insurance or not. In fact, it can often beat your copay. Download the GoodRx app today and start saving. GoodRx is not insurance.
I absolutely love my dog, but the constant shedding, not so much. But then I got a Swiffer Sweeper pet kit, and it is amazing. These super thick cloths pick up a crazy amount of hair. Just look at all that. And that was just from one swipe. And the best part? Sweeper's so much easier to maneuver than a broom or a vacuum, easily getting around chairs and under the couch. You're right. Now I can focus on you, not your shedding. Swiffer Sweeper Pet Kit, because shed happens.
When the protest started this summer, I decided not to join. The main reason was that I didn't want to be let down again. I've been here before. I've marched, I've yelled, and not much changed. But when I did finally go out there, I found some people and stories that got me thinking about this movement in a much different way. And I want to show you. My new podcast, Resistance, is out now. Tap now to listen for free on Spotify.
It's Black Lives, baby.
Hey, sorry folks. My daughter's not feeling well. She's having trouble keeping stuff down. It's been quite fun last day or two. Alright, so we're going to finish up with Chapter 2 here. And see if we can't finally make our programs a little bit more interesting. So far, everything we've done... Oh, thanks, Quinn. Yeah, she'll, I don't know. I think she's hungry, so she wants to eat more than she should when she's just getting stuff down, so it's been rough. Alright, so far our programs have only done the things we've told them to do, and they're not very interesting because they only do the things we told them to do. Right? We give them the numbers, they do arithmetic, they spit the numbers back out, on and on and on. I mean, look at a couple interesting things, I guess, but they're just calculators so far. So, excuse me. What we want to do is we want to make the program solve problems for people and be flexible. Hey, sweetie. Kittens woke up from their nap. So that when we run it, the person using our program can make it do the things we want it to do. Okay? So we can actually be a little bit more interesting here. Let me actually do one more. We'll just keep this a little bit separate here. So we'll do another project here. So this is Chapter 2, input examples. Hey, sweetie. You want to say hi again? Here, come say hi. You want meow? Say meow. She has the cutest little meow. No? Not feeling it? That's okay. Kitty zoomies? Yeah. You have to. Alright, so what we're going to do is we're going to use part of the Java library called scanner. Mr. Gaddis likes to call it keyboard. So remember, it's the type and then the variable name. So we're going to call it keyboard throughout our program. It's a type of scanner. So it's not an int, it's not a double, it's not a string, it's a scanner object. You say this equals, and now we use a new keyword called new scanner. So we're telling Java, hey, I want a new one of these things, and then scanner can do a whole bunch of things. We're going to look more in chapter 4 later, but for now we'll say system.in. Sorry. It's my wife texting. All right. So we'll say, hey, my scanner, I'm going to call the keyboard as a new scanner given system.in. System.in is the standard input. So someone can type in, we can get some input. And right now NetBeans says, oh, we don't know what a scanner is. Do you want to import? And we're going to say, yes, please. So import tells Java, hey, go use this thing from your library. Sorry, the kitten wants out. All right. One out, one in. This one's Merlin. All right. So import says, I want to use this from the Java library. We don't import everything by default. We have to import things essentially one at a time as we need to use them. Okay. So when we use scanner, we can say keyboard dot, and we get all sorts of cool options. Keyboard dot, there we go. And the most common one is next line. So I'm going to recommend you always use next line. There's a bunch of other like next int, next double, next float, next things to get other types, but you run into trouble. And Mr. Gaddis tells you to, just warns you about it here. Oh, thanks, process. I'm going to say next line is probably the best one here. So we're going to say this will be, if I want to get a string value, we'll call a name, and we'll say equals keyboard.nextLine. So whatever we get back from the keyboard next line, we're going to assign to the string we're going to call name. And then I can say hello plus name. So maybe we'll spit out here before that. We'll spit out hello world. Oh, don't climb on the keyboard. No, don't climb up. It's feisty. All right, and now it's going to sit here and wait for me to type something because it's waiting for that next line to be entered here. So I'll say Eric. It says, hello, Eric. Oh, now the other kitten wants in. Hey. Hi, baby. I think she's jealous. So now our programs can finally get input from whoever's running it. And now we can start solving problems for those people here. So maybe we'll ask. We should probably ask, what's your name? What's your name? That way they know what to type. So we usually want to prompt them, and then you want to get their input. And then we can, let's see, what problem do we want to solve here? Let's see if we can, we'll do some conversions for them. Why not? Please enter a temperature in Fahrenheit. Okay, and that's probably going to be an integer. Most of us, when we give Fahrenheit temperatures, don't say 79.5 degrees or anything like that. Now, when you're taking someone's temperature at a hospital, yeah, they'll probably use decimals. But for most people, hey, it's 75 degrees outside. If you told your friends it's 86.4 degrees outside, they're going to look at you funny. All right, so if we want to get an integer value, we'll call this temperature in Fahrenheit. We can't just say keyboard.nextLine. The problem here is keyboard next line gives you a string. It says incompatible types. String cannot be converted to int. So next line will always give you a string value back. So that's why they have those ones that are like next int. But again, we don't want to mess with them because it can cause all sorts of trouble later. Because the enter key, the enter character, like when you hit enter, is actually a character. And if you say next int or next double, it ignores that new line character, the enter key, just takes the numeric part. But then next time you want to go get input, if you're going to go get string input and you call next line, it gives you the enter key instead of whatever the user typed. It's all sorts of trouble. So just avoid it. So if we want to turn this into an integer, we go back to the Java library. We say, hey, Java library, do you know how to do that? And yes, it's an integer.parseInt, given the keyboard next line. So integer.parseInt or double.parseDouble, given some string, we'll try and turn a string into that type. So if we want to have an integer for temperature in Fahrenheit, we can do it this way. So it's this is the conversion step here. Okay. Those are our parse methods, so integer and parse. Always better, I think. All of the classes have them, so byte, integer, short, long, float, double, sure. We can just convert them here. Okay, and then we can do the arithmetic. So we can say that is, and then what is that here? So you take the temperature in Fahrenheit and you subtract 32, right? So we're going to put this in parentheses to force the order of operations. And then we divide that by, so another set of parentheses, right, to make sure we don't get any string concatenation happening. Divided by, what is it, 9 times 5, right, 5/9. No, other way around, divided by 5, no, divided by 9 times 5, yep. 1.8. Yeah. So divided by 9 times 5 should be the same thing as divided by 1.8. Right? And where's my missing a parenthesis? So you notice when I click on the parentheses, it shows the ending parenthesis. So I'm missing the one that ends print line. So it says it's expecting a parenthesis. So now we'll see if we can do this. So let's run our program here. And we should get, hey, I'm Eric, and please enter the temperature. A 212 degrees should be 100 degrees Celsius. Right? The boiling point of water in Fahrenheit is 100 degrees Celsius. Let's run it again. Let's try 32. Right? Any code that's worth writing is worth testing. So we're testing to make sure we did it right, because it's really easy to have typos. So 32, the freezing point in Fahrenheit, because Fahrenheit is stupid, is 0 degrees in Celsius. Celsius is such a better system here. And we probably should also put that down, right? Plus in Celsius. Celsius. Sure. That's right, because we need to declare our units here. All right, let's try some other temperatures. So how about... Eric, 98, and we're not going to do 0.7, so 98 is about 35. And again, we're getting integer division here because all of this is done in integers. If you wanted decimal places, just throw a decimal. So putting it at the 0.5 is not going to do very much because this here will get done first. So if you want to have a decimal result, you need to make sure it's happening in the first step of the arithmetic when we divide by 9. Right? Or we could just divide by 1.8. Sure. Okay. Does that make sense? So we can do some conversions here. And all of this happens with the scanner class, where keyboard, we're just calling it keyboard. So keyboard.next line will give us the line that they enter. Now what happens though, if they give us a number we don't expect, so we'll say, hey, my name's Eric. So if I said 98.7, we get a big, ugly red crash. Here, I'm just going to open this up a little bit more. This is a number format exception. It says, for string input, 98.7. So we can't convert 98.7 to an integer. That's no good, right? That's a double. So the rest of that, it's a little funky to read sometimes, but the main error is actually down here. Chapter 2 input examples, chapter 2 examples.main, at line 19. And I can see, hey, line 19 is where I'm trying to convert here. So sometimes you have to, this is called a stack trace, this error here. You kind of ignore some of the stuff on the top, you read it from the bottom, but these first 2 lines here, just those links, we don't really care. That's just part of the build process. So the first line where it says at is probably where our error is. We had a problem. So the same thing will happen if we try and give it something else. We'll say Eric, and I just say like 10. Number format exception for input string 10. At line 19. Line 19, integer.parseInt does not understand what 10 means, the letters TEN. That's not a number to it. Okay? Does that make sense so far? So we can do all sorts of things, right? We could ask the user, hey, what size circle radius do you have? Sure. Right, so we could have, again, maybe we'll do that final double. You know, we don't even need that. There's already a pi defined in Java called math. So math.pi is already defined as a math constant here, which is super cool we can use. So let's ask for a double input. So we'll say, hey, what's the radius of your circle? What's the radius of your circle? Circle. And then we'll say my double radius is double.parseDouble, because we want to convert a double here. parse double of keyboard.nextLine. Anything they type in here, next line. Yep, so the double.parse double will give you double input here. We can save it as a double. And then we can spit out all that information. What the circumference is, and the area is. So let's do that math, right? So the circumference is pi d, or 2 pi r, right? So plus in here, and we want to do math.pi times radius times 2, pi d, and pi r squared, so math.pi times radius, right? Pi r squared for the area. So for any given circle here, we can find it out. Eric, sure, a number 10, negative 10, okay, sure, what's the radius? We'll say 4. We get 25 and 50, right? I think those are the numbers we got before. Those should make sense, right? 16 times pi, 48 and a little bit more, and then 4 doubled, 8 times pi, pretty close. I think those are right. Right, so this is with a double.parse double. Okay, so this is using the scanner class. So essentially we just copy this line in anytime we use scanner. And then it's keyboard.nextLine. So ask them what to enter and then get the thing that they enter. If it's a string, great, we can just save it as a string. If it's an integer, we need to turn to an integer. If it's a double, we need to turn to a double. Okay. Now, some other cool things. So this math library is fantastic. So we can say here, let's do. Let's just have to enter a number. So we'll say enter a number. Enter a number, including decimal places. Decimal places. Okay, and then we'll have a double for number. Is this thing here? Double.parse double. Right? Double.parse double, keyboard.nextLine. So get the line that they enter, hand it to double.parse double to try and turn it into a double. And then we can print out your number rounded is, and we can say math dot. There's all sorts of cool math things in the math library. One of them is round. You give it a number and it will round it. Let's round the number. Plus, right? Plus. There we go. Okay. So Eric, 10, sure, circle, radius, why not? Or a number with a decimal place. How about 123.45? Rounded is 123. Okay, seems good so far. Let's try to make sure it can round up. It's Eric, 10 degrees, sure, radius of 4, why not? How about 2.5? Rounded up is 3, right? Or rounded is 3. Right? Remember, 0.5 will round up, anything less will round down. So rounding is good so far. There's also math.ceil, which will go to the next highest number, or math.floor, which will go to the rounding down. So instead of rounding up or down, it will always go down here, which is really cool, right? When you just start typing, it gives you, this is from the Java API. You can go look this up if you want at that Java API website, or we can just see here, it returns the largest, closest to positive infinitive double value that is less than or equal to the argument and is equal to a mathematical integer. Largest value that is less than and is a mathematical integer, right? It rounds down all the time. So math floor and math ceil are fantastic. Okay? All right, you folks with me so far? So let's take a look at our first project here then. So let me come back and grab our D2L site here. Look at that. Oh, I had Mr. Gaddis' slides up. Oh no, I hit close. That was the wrong thing to do. That's okay. We probably shouldn't have shown his slides anyway because they're copyright protected. So it's okay, we'll pretend that didn't happen. Let's come back to 1500, go to assignments. All right, this is project 1. Okay, so again, Memorial Day we don't have class. So usually everything is due in 2 weeks, but because we're off that week, it's just going to be due on the 7th instead at 6 p.m. because at 6 p.m., the first thing I'm going to do on June 7th is go over the solution to this. So let's add a new grade here for project 1 in projects. Okay. Excuse me. And this is a text submission here. All right, I'll give you a link here to Google or GitHub Classroom here in a minute to give you a repository. And so in that repository, so you're going to make your project in the repository. Make a new project in the repository created from above. Again, it's not there at the moment, but that's okay. Submit URL to the feedback pull request in that repository. And what I'd also like you to do, along with a self-assessment using the rubric. So I'm going to add this rubric here in a minute, and it'll show you, you get a point for this, 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 on and on and on. Okay, so you're going to take that rubric and assess yourself in the submission. So give me the link, and hey, check this one off, check this one off, check this one off, or I missed this one, but I got this one, I got this one. Whatever. You get partial points, right? Any of the things you complete, you get. Anything you miss, you don't get. Okay? Excuse me. So we're going to build a, let's say, we want to say like a semester calculator. It's not even a semester calculator. Right? All right, so we'll write a program. There we go. Program that helps the user calculate how many more semesters of school they will have to complete their degree. We're assuming they're going to get an associate or bachelor's, right? So we'll ask them, you know, how many credits you need, that sort of thing, along with the total cost of the credits. Make the home tasks. Yeah, D2L is not terrible. It's just not as pretty. All right. So to start, it's the user for their name, and use their name when prompting for other information. Right. So like we did, I said, hey, what's your name? Right. We need to use name. I said hello name, but like I should say, hey, name plus. Right. Please enter a temperature in Fahrenheit. So then we're using their name in the prompts here. So hey, what's your name? Eric, and it says, Eric, please enter a temperature in Fahrenheit. We're going to make the program nice, right? It's going to be friendly. Okay? So ask for how many total credits are required to complete their degree, or how many credits they have complete. Credits they have completed already, right? Calculate the remaining credits. Ask how many credits you take in a typical semester, right? So, you know, 12, 13, 14, 15, whatever they want to pick for, they're going part-time, right? Any way they want to pick here, then. And then we're going to ask for the cost per credit. And then we're going to calculate the more semesters are required to complete their degree, and the total cost of the remaining credits. Okay? Does that make sense what we're asking and what we're calculating here? Okay, so on our rubric here, let me go add this. This is project 1. Again, we don't need some of these middle sections here, I'm sorry. Take those out. So if you don't have it, it's missing, you get no points. If you do have it, it's completed, and you get a point. So you're going to use this rubric here when you do your self-assessment. So program user for their name. The program uses the user's name in all the following prompts. Right, so a point just for asking, and a point for actually using it. They'll enter, right? You say, how many credits do you need for your degree? If you're getting an associate, you'll probably enter 62. If you're getting a bachelor's, 120 something, like 127, 125, I forget the exact number, right? So they'll enter the number. So our program will work for anybody. How to calculate with a few variables the amount, right? So if you know how many credits they need and you know how many they've taken, we can do the arithmetic to find out how many they have left. That's camera's over here. How many are left, right? If you know how much you need, minus how many you've taken, will tell you how much you have left. Okay, and then so asks for total required credits. Required credits. Let me add some more here. Asks for credits already completed. Asks for cost per credit. Calculates total number of remaining. Oh no, we need to ask for. That's right. So ask for how many credits are taken per semester. Right. Calculates total number of remaining semesters. And calculates total cost of remaining credits. Okay. So this one here, right, your total number of remaining semesters needs to be a whole number. Okay? You can't tell me I have 2.5 semesters left. You can't take half a semester of class. Right? It just doesn't work like that. So you need to be careful with your arithmetic when you're calculating how many semesters they have left. So if you have 20 credits and you need 62, right? Let's just, you can kind of sketch this out. I definitely encourage you to do this sort of thing. This is like pseudocode where you're kind of just sketching out in English what needs to happen, right? And what our formula is, what our algorithm is for this. So if I say I need 62, right? And I have 20, and I take, let's say 14 credits per semester, right? 62 minus 20 gives me 42 credits left. 42 divided by 14, right? 28, 42, is that an even 3? Right? That's an even 3. 42, great. But if I take 12 credits a semester, what is 42 divided by 12? Well, 3, right, is going to give me to 36. And then I'll have 6 left over. 63.5. You can't take 3.5 semesters, right? You have to take 4 semesters. Your last one won't be 12 credits, but that's okay, right? We're saying at this rate, it's going to take you this many more semesters to finish. So make sure that it's a whole number, right? You don't want integer division to round down, right? You want to round up with like that math.ceil we looked at real quick. And math round is wrong. Don't use math round. Right? Make sure you're rounding up there. Right? So here, we'll do this 2 other ways here. Rounded down with math.floor and rounded up with math.ceil. Ceil is short for ceiling. Okay? So you got some little tricks there for you. Yes, so ceil will always round up. It's the next closest number. Yep. So if we run that, all right, we get Eric, you get a temperature in Fahrenheit, we get a radius of a circle, sure, a number. So like 4.2, rounded is 4, rounded down is 4.0, rounded up is 5.0. Okay, so we commit this here. So this is some input examples. Commit and push. Okay. So that's our rubric here. And this overall score thing is done. We don't need this. We get rid of that. Okay, so if you forget to use their name all the time, you're only losing the 1 point here. If you're still prompting them, right, these asks, ask them to enter the information, great. Okay, overall score, this is silly. I'll attach the rubric. We'll say that is 8 points for this one here then. Oops, 8 points here. And give me just a second, I gotta go do that classroom thing here. Classroom.github.com. Oh, that's right, I gotta make a new one too. Sorry, I forgot to make this link earlier. Give me just a second here. So do 1500 summer 1 project template. Java, ignore, create Awesome. This one's good to go. Make it a template. So in our classroom here, we go add a new assignment for project 1. And let's do 1500. CIS 1500 summer 2021 project template. Here we go. Hey, long-range missile. How you doing today? Don't need any tests. We'll do feedback pull requests. Here we go. This will just set up a nice little repository for you to use, which is nice. Edit this one. Okay, so there's the link for you. You can click that one, use that repository, clone it, create your project in that folder, and we should be good to go. All right, again, don't forget the Chapter 1 quiz is due tonight, 11:59 p.m. I'll be posting the Chapter 2 quiz shortly. We'll have a week to do that one as well, and then we'll just keep on going through our content. Next week we pick up Chapter 3 and make our programs do even more interesting things. All right, any other questions? Sorry, it's fine. I ran a little long. I'm hoping not to go so close to 9 every time. But it's just a lot of content to get through here in Chapter 2. All right, so we got 3 weeks to get this done. A study group this Wednesday at 5. You folks are welcome to talk to each other about the project. The point at which you start taking notes, though, is when you are working too closely together and getting into that realm of academic dishonesty. Right? If you just want to chat together and say, yeah, I might do this, I'll do this step, I'll do this step, I'll do this step, fantastic. But if you're taking notes, right, copying off of what they're doing, we've gone too far. So in study group, you can get together, you can talk about it, look at how we use some of these tools, make sure we're parsing, doing the right keyboard next line stuff. That's all fantastic. If you have questions, please feel free to put them in the course Discord. Right? That way anyone else gets to see the question and my answer to it. Keep an eye on that. And then if you'd like to meet for my office hours, again, Monday, Wednesday, I'm going to do 3 to 4:30 and then 10 to 11, because some people said late at night was fantastic for them. So I'll try and catch as many people as I can that way, and you can always schedule an appointment to meet with me at another time. Just shoot me a couple options, and I'll see what I can do to try and be flexible. Yeah, we got class next Monday, 5:24, but not Memorial Day. And we're just going 1 chapter a day through week 14. We'll have a couple miscellaneous topics, and we'll have some time for our final project, and then we'll present on 8/23 synchronously over Zoom. You get to show off your amazing game. We'll have a lot of fun. And that is the rest of your summer planned out for you. Hey, Aquas. Glad to have you following along. Okay. Any other questions, thoughts, concerns? I'll be around the rest of the night if you have questions. Class usually goes to about 9:45 or so. The midterm will be up through 1 through 7. Okay, awesome. Well, if you don't have anything else, let's see who else is around on Twitch. We can go pester. We've sent a raid off somebody. Oh, thank you. All right, who is around? I wonder if we can raid this one here. Let's see if we can or not. I'm not sure. I need to copy paste that. Thanks. Oh man. Oh goodness. Oh, this Twitch Inception is making it unhappy. Oh man, I almost had it. The midterm will be similar to our quizzes, and then with some long answer questions. So it'll be a mix of the short answer style quiz questions and then some long answer questions. I'll give you a practice one before. Don't worry too much. As we get closer, we'll get into some of the practice ones. Does not like loading that at the same time. Makes it really unhappy. Can we hit that raid? Oh, we can't raid his channel. Bummer. Alright, never mind. That's no fun. What else is around? He must be actually teaching his class. I don't know. Alright. Maybe we'll just hang out here then.
Question.
No. Ouch. Kitty. We can go check out Boyd. Boyd's having fun. He does some cool fabrication work. Split over that way. Say hi if you're into it. Should be a lot of fun. I'll see you folks next week. Give me a call. Text me. Find me in Discord. Whatever you need to do to get a hold of me. See what I can do for you, okay? You take care. Maybe it'll raid. There goes.
Not sure
Yeah, you'll be able to see your quizzes once they're graded.
if I know many people who haven't.
Come on, click the raid button. I can't make this work. That's super laggy, I'm sorry. Yep, yeah, you'll be able to look at them. I'll open those quizzes up.
Mini, yours is a diode butter. That's really good result for a diode laser. I didn't know that. I just assumed it was CO2 because it looks really good.